Hello guys, welcome to Vedantu NEET English. I'm Miss Gopika, your own biology master teacher. I hope I'm audible, visible and the presentation right behind me is visible. Please let me know in the chats if we are live yet, and let me also inform my Telegram students to come and join. Yes, are we live? Done. I think we are live, right? Oh. Awesome, we are live. Hello students, those who joined right now, quickly mark your attendance, and that is by smashing the like button. Okay, mark your attendance and then we will directly get into the class. Okay, I'm doing great. Thank you so much for asking. I hope all of you are also doing great. Today I've done the class a little early because I have another class, so that's the reason the class is a little early today. Otherwise usually it's at 12 itself. Okay, yes, even Saturday's class is going to be little early, students, because Saturday and Sunday is my festival. I think all of you know Onam, so that's why Saturday's class also will be 1 hour early. I will inform you the timing. Mostly it will be at 5 or 4 because all of you come back early on Saturdays, no, half day, right, in college. So I thought I'll do the class early. Okay, hello. Yes students, yes, hi Amu ma'am, hi. So students, what did we do last class? So lecture 1, those who haven't seen lecture 1, okay, you need first hittings. Okay, first you need hittings for not watching the lecture 1 and being in lecture 2. But those students who were there in lecture 1, all of you know that we have discussed about endocrine gland. Okay, endocrine gland. Then we spoke mainly about hypothalamus, pituitary, who is the master gland, right? It will regulate and control other glands. Then students, we went on to go one by one. So then we went to pineal gland, okay, thyroid, parathyroid, then what? Thymus. Yes or no? Yes or no? This is what we did, correct? Chalo, I cannot see the attendance. I want immediately 50 likes to happen. Come on, you guys can do this. Come on, all of you. Yes, all of you smash the like button. Okay, I keep confusing smash the like button. So students, we understood what is endocrine gland. We also understood what is exocrine gland. We also understood what is composite gland or heterocrine gland or mixed gland. Many names it has. Okay, heterocrine gland, mixed gland. Yes or no? Then what else did we do? We did hypothalamus, who is like the principal, right? The principal who will understand everything. So principal, then we have pituitary gland, then we have pineal gland, then we have thyroid, parathyroid and thymus. These are the glands that we studied. So today what are we going to do? We are going to start with adrenal gland. For those students who do not know, we are doing NCERT line by line, where every paragraph of NCERT will be put and we will go line by line of NCERT. Then I will do GM Express, that is Gopika ma'am Express, which will give you the notes like a short note. No, I'll give you like around 5 to 6 slides which has an entire content of the entire chapter. Okay, entire chapter or maybe the lecture. So last lecture also we had around 5 to 6 slides which was the entire lecture overview. Okay, yes, all my new students, welcome you all. I cannot keep calling each of your names, that is the reason. So all of you, I know all of you are there. I'm watching your names, very good. Okay, so welcome all of you. Quickly subscribe to the channel and also hit the like button, because only if you like, then YouTube will also know that okay, this girl or boy is interested in NEET syllabus and NEET chapters, not in any other things. Okay, chalo. Now students, look here. Our body has one pair of adrenal gland. Now where is adrenal gland present? Okay, morning only started for me, tongue twisting. So this is our kidney, right? This is the kidney. On top of the kidney, right, just above the kidney, we have a cap like structure which is called the adrenal gland. What is the full form of adrenal gland actually? Ad means above. Okay, ad means above, Renal means kidney. I've always told you this, no? Renal means kidney. Anything renal comes, that means it is kidney. So above the kidney, I am present above the kidney, right? Yes. So look here, our body has one pair of adrenal gland, one at the anterior part of each kidney. Okay, the topi for kidney is adrenal gland. Yes or no? Very nice. Now the gland is composed of two types of tissue. Students, we all know that whenever we categorize something, we always learn about medulla, cortex, right? Even in kidney we had learned, okay, we had a renal, that is renal cortex and renal medulla. Yes or no? In that only we saw about medullary pyramids and all of that. Same way in adrenal also, there is a renal and a cortex region. Outer cortex region, inner medulla region. Okay, are you all with me? Chalo, very nice. Now look here, the centrally located tissue is called as the adrenal medulla. So the center portion of the adrenal gland is called as the adrenal medulla, and the outside is called as the adrenal cortex. I'll draw and teach this, don't worry. Now, underproduction of hormones by the adrenal cortex, okay, alters the carbohydrate metabolism, causing acute weakness and fatigue. Fatigue means tiredness, okay, leading to Addison's disease. So here what is the problem with NCERT is, it directly went into the disease before explaining you about the adrenal cortex and adrenal medulla, okay. Later in the parts of the chapter they will be explaining. So we will keep this underproduction there only. We are not going to look into Addison's disease now, okay. We will directly go into the rest part of it. Now look here students, the adrenal medulla secretes two hormones. How many? Two hormones. Okay, are you all with me? Any doubts so far? Yes, yes, call each other. Students, attendance, come on, attendance is important. From where did you guys join? First time you're seeing the channel? Okay, adrenal medulla secretes two hormones called adrenaline or epinephrine. Two names are there, okay, or non-adrenaline. Students, all these notes you will get it on Vedantu NEET English Telegram or Biology by Gopika and Biology by Gopika. So you can join any of these telegrams to get all the notes, okay. Now students, what are they telling? Whenever you're going to write exam, right, whenever you're nearing to your NEET examination, what is exactly going to happen? You will start having panic, you will start shivering, your hand will start sweating, your heartbeat will increase, you will have pillow erection where your hairs will start standing. All this is common, yes or no? How is this caused? This is because of your adrenaline and non-adrenaline. These are your 3F hormones, that is, they do the 3F. Okay, a dog is coming to bite you. How will you know that you are panicking? You start panicking. That is because these hormones are released during the fight, okay, flight, and what? One more, fright, okay, scared, fear, okay, fear. You can also write fear. So during a fight, that means during a stressful condition, again during flight, okay, during fright, not this flight, the flight, oh my god, I have to do this, I have to do that, I have to do that, okay, that panic mode, right, that panic mode, when it happens, your adrenal medulla is the one who secretes adrenaline and non-adrenaline, okay. Now, these are commonly called catecholamines. So I will give you a flow chart which will help you understand everything. Right now you just try to read NCERT with me, okay, try to read NCERT with me. Now, adrenaline and non-adrenaline are rapidly secreted in response to stress. So students, now are you in stress? Yes or no? Are you right now in stress? No ma'am, I'm right now not in stress because it is only September. I have still 4 to 5 months for NEET. I am not at all stressed. But if I ask you the same question on May 4th, you'll all be on your tip, right? You'll be like, ma'am, I'm very stressed, ma'am, let's not talk about NEET itself, right? Why is that? Because your hormones have started working, your body is during a stress condition. If a student is not going through stress, then what do we tell? Oh my god, you really have some problem, right? Because your hormones are not getting released. So during stress condition, this will be maximum focused on releasing it and you will feel it. Okay, you will feel it. So look here students, so these are also called as emergency hormone. I will call these hormones as emergency hormone. That means during an emergency situation, these are the hormones that work, and these might be one of the reasons why sometimes our brain don't work also, okay, because These hormones get released in such a higher amount that we cannot process some things, right? Now we tell, no, why didn't she do like that, why didn't he do like this? When we see a scenario on TV, okay, when we see a scenario on TV and we feel like, okay, this girl was hit by someone or this boy was hit by someone, we'll be like, why didn't he react? Yeah, he had a situation, no? Or we see a road rage, that is on front of our car, 2-3 people have come, okay, and we see that video. Immediately we'll be like, oh yeah, why didn't this fellow give the accelerator and just push these people away? But during that time, when we are at that moment, okay, what happens? These hormones get secreted and all our impulses, okay, sometimes it works, students, sometimes maybe at a very faster rate we'll be immediately able to think that, okay, I am supposed to behave like that, but sometimes it weakens, the impulse weakens, and there will be full confusion in the brain, okay. That is why we will not be able to react at that moment, and later after that day night you will be like, I should have reacted like this, I should have told her like this, I should have told him like this, okay, you go, it will never affect me, or let she go, it will not affect me. But that time what you would have done, you would have cried, or you would have told, please stay, don't go. Some situations like that would have happened. Yes, and I'm relating to your life and telling. Emergency situations are called as emergency hormone, okay, emergency hormone, or hormones of fight or flight. These hormones increase alertness. See, what are the things, okay, that you notice during this secretion is that first thing, your pupil gets bigger, right? The pupil dilation will happen. Your pupil will get bigger, okay, dilation will happen. So first alertness will be there, then pupillary dilation will happen, then piloerection or your racing of the hairs, okay, then sweating is one of the symptoms, okay. Now both the hormones increases the heartbeat, duck 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 duck, you can hear that, no, duck 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 duck, okay. So the heartbeat will increase, the strength of the heart contraction and the rate of respiration also will increase. You will be trying to catch your breath, okay, you'll be like, oh my god, I have to calm down, I have to calm down. So that kind of breathing, you'll try to catch your breath, okay. Now catecholamines also stimulate the breakdown of glycogen, okay, breakdown of glycogen or glycolysis, okay. So breakdown of glycogen will happen, that will release glucose, okay. That is the reason why people tell, no, during stress condition you have tendency of putting on weight or losing weight. All this is because other metabolisms are also connected, okay, other metabolisms are also connected. Yes, whenever like how Akshay is asking, whenever someone tells result is out, bro, your result is out, what happens? Adrenaline, non-adrenaline get released, you will have heartbeat increase, you will try to find your breath, you will also try to find where mom has kept all the broom, chappal, everything, and you will also have hair, goosebumps will come, no, that goosebumps feeling will come, sweating will start, all of this will happen, okay. And increased concentration. So students, the glycogen will break, right? The glycogen will break down to release glucose, okay. I have made you a table for that. When I teach you pancreas, I'll teach you in detail again. Now look here, in addition they also stimulate the breakdown. So lipids and proteins also breakdown is happening, okay. Proteolysis also is happening, okay, proteolysis also is happening, okay, proteolysis also is happening, that is breakdown of lipids and carbohydrates, okay, lipids and proteins, as well as glucose, glycogen is getting broken down. Now students, listen to adrenal cortex. I have made a way to remember this also, which I will tell you very soon. Now listen to me carefully. The adrenal cortex can be divided into 3 layers. That is, if I divide the cortex, I will have 3 layers of the cortex, okay, 3 layers of the cortex. What are they going to be? Zona reticularis, which is going to be the innermost layer, okay, zona fasciculata, which is going to be the middle layer, and then zona glomerulosa, okay, zona glomerulosa, which will be the outermost layer. You might have a chance of getting it confused with your ovary there, okay, ovary there, don't get it confused, try to remember, I'll tell you. Okay, I'll tell you how to remember also. Now, the adrenal cortex secrete many hormones commonly called as corticoids. So the hormone released by the adrenal medulla will be called as catecholamines. The one released by cortex will be called as corticoids. So you will not get confused, okay? Corticoids, cortex, corticoids, cortex. Okay, that was medulla, catecholamines. Okay, I'm going to write and explain this. Don't worry. Now try to read this NCERT with me. Okay. See, the corticoids which are involved in carbohydrate metabolism are called as glucocorticoids. Okay, glucocorticoids. corticoids. Now, in our body, cortisol is a main glucocorticoid which helps with this glucose metabolism. Okay, which helps with this glucose metabolism. So, look here, cortisol is a main glucocorticoid. Corticoids which regulate the balance of water and electrolytes in our body are called as mineralocorticoids. Example is your aldosterone. Okay, aldosterone is the main mineralocorticoid in our body. Now, students, look here. Before I come into this, let me try to make you understand. Now, we will try to understand adrenal gland from starting. Okay, from scratch. All of you ready? All of you ready? I don't want anyone to sleep in the class. Okay. Okay, chalo. Now, students, first thing, adrenal gland. Okay, adrenal gland. Where is it present? It is present. So, from the name itself, we will write ad means above. Okay, above. Renal means kidney. Okay, renal means kidney. So, it is present above the kidney. Okay, this is present above the kidney. Now, next thing that they have told is this adrenal gland has two. Okay, adrenal gland has two layers. So, I am going to draw it. I think it became too big. Okay, students, I am drawing the innermost layer. Okay, next layer. Okay, is it visible? Yeah, it is going to look like you know that cascata ice cream, casata, I don't know the exact pronunciation of it, but yeah, it will look exactly like that. Okay, this should become a triangle. That is the task of the day. Okay, one more layer I have drawn. One more layer we have to draw. Okay, one more layer. Oh. Okay, can you see, students? 3 layers. Is it visible? Okay, yes, fine. So, look here, I have drawn 3 layers. Now, let's start labeling these layers. Okay, let's start labeling these layers. The innermost layer, okay, the innermost layer is going to be your adrenal medulla. Yes or no? Adrenal medulla. Now, the outermost layer, next is going to be cortex, right? This is your entire adrenal gland. Let's say this is your entire adrenal gland. Okay, this is the entire adrenal gland. Now, looking like ice cream only, no, I told you guys. So, now students, outermost layer, the green one that you are seeing is going to be called as what? Zona glomerulosa. Okay. Okay, zona glomerulosa. There is a way to remember, you can either remember it as GFR. Okay, GFR. Glomerular filtrate rate, no, like that only you can remember this. Next layer, the one that you're seeing in orange, is going to be called as zona fasciculata. Okay, fasciculata. The last layer, the one that you see in pink, is going to be R. R for what? Zona reticulosa. Got it? Any doubts? Yes? Okay. Reticularis. Okay, laris. Reticularis. Yes, done. So, these are the 3 layers of your adrenal cortex. So, these 3 layers, okay, these 3 layers belong to the adrenal cortex. So, you can remember it with GFR, okay, you can remember it with GFR to remember the layers. Now, adrenal medulla is there. Now, students, what did they tell? what did they tell? This adrenal gland, especially your adrenal medulla, releases the 3F hormones, right? So adrenal medulla, if I have to tell, okay, if I have to tell adrenal medulla, I can tell that adrenal medulla releases the 3, during the 3F it is going to release the hormones, or else I can also call it as the emergency hormone. Yes or no? I can also call it the emergency hormone. So during the fight, fright and flight, these hormones are going to get released, okay? These hormones are going to get released. Now, each of the session, students, one hormone is going to get released. Now, the question comes, are they under ACTH or are they going to fall under your adrenocorticotropic hormones? Okay, that is a question which we will go through slowly to understand if they are actually in control or they are not in control, okay? Now, understood, ma'am, they are above the kidney. Yes, they are above the kidney. So students, the one that I have drawn there, no? Now let's say this is the kidney. The diagram which I have drawn there, you can see it is a triangular structure. Yes or no? It is a triangular structure, and if I have to draw the inner layer, this is how it is going to look like. Okay, you have a diagram in your NCERT, you can look at the diagram and you will be able to understand how did I draw the structure, okay, how the cortex and medulla is differentiated. Any doubts so far? No, right? Okay. Now students, if I have to write about the, okay, I'm just drawing this here, okay, so it will be visible and you will be able to understand. Now, I'll give you an idea about what NCERT was trying to tell about the hormones. See, a triangular structure. Okay, now inside this triangular structure, you will be able to see one more region, which is the medulla region. Okay, chalo. Okay, understood, ma'am. Now, here I'm writing adrenal gland. Okay, 2 regions. What are the regions? Cortex. Okay, adrenal cortex and adrenal medulla. Okay, adrenal medulla. Yes, clear? Now, according to that, what did they say? What did they say? Students, all of you focus here. If you don't understand this, it's going to be difficult. Let me tell you, this chapter is among human physiology. Lot of terms to remember is it from this chapter, okay? Rest everything we can explain it, okay? Rest everything we can explain it. Yeah, Bermuda Triangle only. Now, students, they told that adrenal cortex, okay? Adrenal cortex gives out corticoids. Corticoids, yes or no? This, if you understand, I'm telling you, you will be able to understand everything, okay? They told that adrenal cortex will give out corticoids, yes or no? Now, what is adrenal medulla going to give? Adrenal medulla is going to give catecholamines. Catecholamines. Is this clear? Okay, under this corticoids, you are going to see glucocorticoids, mineralocorticoids and sex corticoids, that we will keep it apart. Now, under adrenal medulla, they are going to release catecholamines. Catecholamines have 2 parts, again, adrenaline and non-adrenaline, or epinephrine and non-epinephrine. Okay, so this much is clear, students. What did we study? We studied that adrenal gland is above the kidney. It is a triangular structure and that has 2 regions, which is called the adrenal cortex and adrenal medulla. Cortex is the outer region, medulla is the inner region. Cortex will release corticoids, medulla will release catecholamines, which will be further divided into adrenal and non-adrenaline. Okay, now if you see here, cortex is made up of 3 layers. The outermost layer is called as zona glomerulosa, inner layer is called as fasciculator, and the outermost or the innermost layer, okay, not the outermost, innermost layer is going to be called as reticularis. Clear? So far perfect? Okay, chalo. Now, they have told, okay, now is the main portion. I'm going to tell you about the hormones secreted by each layers, okay, each layer. So, I want all of you to focus here, not anywhere else, okay, first layer, second layer, and I'm also going to give you the functions, okay. So, when we read the next paragraph, it's going to be super duper easy, okay, all your concentration here. Yes, definitely Puneet, adrenaline is also called as epinephrine and non-adrenaline also called as non-epinephrine, okay. Yes, the doubt is clear. Now, look here students, the first portion was called as zona glomerulosa. Yes or no? Any doubts in this? Zona glomerulosa. Yes, this one, okay, this one mainly gives out the mineralocorticoids. Okay, what are they going to give? Secretes the mineralocorticoids. Secretes mineralocorticoids. And the most important mineralocorticoid that you have to remember is your aldosterone. Now, students who have followed my human physiology till now, tell me, where did we study aldosterone? In the chats right now, tell me, where did we study aldosterone? Quickly. Yes, very good. Where did we study aldosterone? I've taught you aldosterone mechanism in a very beautiful way. Now tell me, where did we study? Which chapter did we study? What were their uses? Anything you can tell me. Anything that you remember. Yes, correct. Who's going to tell? I just want one word. If you tell me that one word, I know that you know the concept. Okay, aldosterone. Very good, Madhumati. Excretion chapter. Very good, Soni. Where did we study in the excretion chapter? We learned it under RAAS mechanism. That is renin, angiotensin, aldosterone mechanism. Right? Aldosterone system. Now, students, aldosterone is mainly controlled by the RAAS mechanism. Okay, RAAS mechanism controls this aldosterone mechanism, not the hypothalamus or the ACTH. Okay, that is not controlled by the cortex itself. It is going to be controlled by the RAAS mechanism. Why so? Because whenever the GFR rate reduces, aldosterone will be secreted after the renin is secreted. Renin will go and convert angiotensinogen to angiotensin. Okay, after angiotensin, it will be converted to angiotensin 2. Angiotensin 2 will secrete aldosterone, telling that now you have to do reabsorption of sodium, you have to do reabsorption of water. So the osmotic balance, the GFR rate and the blood pressure, blood volume, all of this will be maintained by aldosterone. Got it? Okay, aldosterone. So look here, students. So what we are going to write? We are going to write about aldosterone's functions. Okay. So aldosterone is going to do reabsorption. Okay, reabsorption of sodium ions. Yes or no? Okay, sodium ions reabsorption it is going to do. It is also going to do absorption of water. Okay, absorption of water. It is going to help in the maintaining, okay, it is going to maintain blood volume and blood pressure. Okay, blood pressure. Yes or no? All this we have studied in RAAS mechanism. It's nothing new for us, right? Now, students, whenever they are doing reabsorption of sodium, remember that they are going to give out, okay? They are going to, what we tell, throw out, no? We tell, no? Like excrete out or like throw out the potassiums, okay? Potassium ions. Have you ever heard about this? Yes or no? Yes, tell me. Okay, so students, whenever they are going to do reabsorption of sodium, remember that they are going to do excretion of potassium and phosphate ions. Okay, potassium and phosphate ions. I hope phosphate formula is correct. PO4, no? I don't know this one, valency and all of that. Students, colors are all same, huh? So much same colors, everything looks. Actually, colors are very different, but I don't know why it's looking same. Okay, students, they are going to do, so whenever they do absorption of sodium, they are going to do excretion of potassium, okay, excretion of potassium and phosphate, okay, phosphate ions. Is this clear? This is important, that's why I'm telling you, okay, phosphate ions. Done? Okay, so they are mainly, yeah, blue, everything looks nice. So they're mainly going to do the balancing of the GFR. And aldosterone or your mineralocorticoid, main one, aldosterone is going to be controlled by your RAAS mechanism, not by your ACTH. Okay, I told you this tropic hormone and non-tropic hormone. Tropic hormones are the ones that will go and stimulate another gland. Okay, but non-tropics are not like that. Okay, so here you have to remember that adrenocorticotropic hormone has to control some things, so regulate some things. Aldosterone will not fall under that. Aldosterone will focus on RAAS mechanism. If renin is telling me that I have to come out, or angiotensin 1 is telling, or 2 is telling me that you have to come out now because you have to do reabsorption of sodium, I will come out and do reabsorption of sodium. Okay? Yes. All confused people. Every day I meet confused people. Why, students? And why am I not getting some good, okay, students who are like, they give good dana telling, ma'am, take ma'am, you deserve this. Okay, zona glomerulosa secrete mineralocorticoids. Main mineralocorticoids is aldosterone. This is the main function. At least try to remember as much as possible. If at all you forget, no, just write about the RAAS mechanism. Okay, RAAS mechanism you people are pakka, no, so write about RAAS mechanism. Next one is what? Zona fasciculata. Okay, zona fasciculata. What will this one give out, students? Can you think? What will this one give out? Yes, zona fasciculata. It is going to give out cortisol. Okay, cortisol is going to come out from this, and cortisol is a very, very important person for what? They told you glycogen breakdown, right? Glycogen breakdown it is going to do. So cortisol is going to help in different functions, like, okay, to break down glycogen, to release glucose, okay, to release glucose. Okay, you can also write glycolysis. Glycolysis, lysis means breakdown. Okay, it is also going to do proteolysis. Proteolysis, that is breakdown of proteins. It's also going to do lipolysis, that is breakdown of lipids. Okay, but it is very important role is to do this. Okay, maintain the glucose, right? They are going to help in this. So cortisol, zona fasciculata will release cortisol, which is a it's a glucocorticoid. Okay, so I'll write here, it secretes a mineralocorticoid, like that I'll write here. Okay, otherwise you might think that, ma'am, how come this is not there? Give me 1 minute, I'm just writing it. Okay, this one secretes glucocorticoid. Okay, glucocorticoid. Out of that, the main corticoid that is going to come out is going to be your cortisol. Now, no doubts, no? Now, same flow we are following. See, secrete mineralocorticoid, secrete glucocorticoid. Main one is cortisol. Here, main one was aldosterone. Any doubts in this, anyone? Yes, tell me in the chats. I'm checking the chats on my phone as well, because there it is slow. Okay, students. This one, okay, this is going to increase the blood glucose level, because it's continuously breaking down the glycogen and glucose. So what this fellow is going to do, no? Students, imagine this, you people answer me this. Okay, this is the blood vessel. Okay, inside this blood vessel, let's say lot of glucose is there. Okay, lot of glucose is there. These are our cells. Okay, these are our cells. Now you tell me, if this fellow wants to increase the glucose level in the blood, will it allow cellular uptake or will it prohibit cellular uptake? Tell me. Yes, I will do that. Puneet, I am going to do glycogenesis, glycolysis, all of that I have done. I am one step ahead. Okay, you will already see a PPT, I mean a slide, which I have already written. See, it's already written here. Okay, so wait little, I will teach you this. Students, you tell me this, think and tell me. If this fellow wants to increase the blood glucose level, will it inhibit cellular uptake or will it promote cellular uptake? If you people answer this, that means this much is clear. Okay, answer fast. Will it inhibit cellular uptake? Okay, will it tell the cells you use up all the glucose, or will it promote, telling that you go do it, or will it prohibit, like prohibit, promote, okay, or inhibit, promote? I understood. Yes, cellular uptake I told. Will it prohibit? Will it stop? Okay, will it inhibit or will it promote? Will it inhibit or promote? Okay, one answer I got. Let's see if it's correct. Okay, I want all of you to tell me. This again I'm telling you, this one wants to increase the glucose level in the blood. So this is the blood, right? This is the blood. These are your cells. So uptake will happen, intake will happen or not? Very simple question. Very good, very good, perfect. One student also did not answer wrong. I'm so proud of you people. Students, this fellow, if he wants to increase the blood glucose level in the blood, why will he allow the cells to utilize it? So it will, very important, it will inhibit, okay, it will inhibit cellular uptake. Very good, students, so proud of you. I'm so happy that all of you answered, okay? Cellular uptake. Is this clear? Now, not only that, cortisol plays a very, very important role in anti-inflammatory response, at the same time to suppress the immune system, right? When we do like graft transplantation, when we do, before graft rejection shouldn't happen, what they will do, they will suppress the immune system as well, okay? They will suppress the immune system as well. So this is also a very important role of your cortisol. Students, I've written more functions, so in case in the exam you forget something, you will be able to remember at least one among it, okay? It will suppress the immune system. Got it? It also has anti-inflammatory response. It also helps in cardiovascular systems, but that's a lot information, so at least try to remember this much, okay? These three are very, very important. You cannot forget it because it's NCERT lines. Done? Yes. Chalo. Next one, students, which is the last layer? Last layer is zona reticularis, okay? Zona reticularis. This slide is very important, okay? Take a screenshot of the slide when I'm sharing the notes with you, okay? When I'm sharing the notes with you, keep the screenshot ready. Now, what is this going to secrete? These are going to secrete your sex corticoids, okay? Secrete sex corticoids, okay, or you can tell gonadocorticoids also, okay? Now, sex corticoids, what are they going to do? They are going to help in the growth of the secondary sexual character. They are going to help in, hair growth, other things. You can generally write about it, okay? You can generally write about the characteristics of them. Nothing specific you have to remember. Just write whatever you remember about the secondary sexual character, okay? Secondary sexual character. So, they are mainly going to help in the growth of secondary sexual character, okay? Secondary sexual character. Now, ma'am, it's too difficult to remember so many things. Each of them are secreting one thing. It's too difficult to remember. So I made a way to remember this. Just let me know if it's going to help or not, okay? So remember this, okay? GM, that is glomerulosa will secrete mineralocorticoids, okay? This one is going to be F, okay? G, that is fasciculator will secrete glucocorticoids. Then zona reticularis, RS, okay? RS. Now, how are you going to remember this? You have to remember me. You will remember that Gopika ma'am feels great reading science. I'm looking, okay, what did I make? I make suddenly and then I forget, okay? So, you'll remember like this, Gopika ma'am feels good reading science, okay? I love science, so obviously I feel great when I'm reading science. So, Gopika ma'am feels great reading science is how you're going to remember this, okay? Done? Yes, you'll remember. Should I write it somewhere? Okay, reading science. This is the way to remember this. Students, this is very important topic, okay? Okay, this is what a brain, ma'am. Yeah, I know, my brain works differently, it is wired, okay? So, sometimes, look here, zona glomerulosa, so glomerulosa mineralocorticoids, GM, okay? Fasciculator, glucocorticoids, FG, okay? Reticularis and sex corticoids. So, you will remember Gopika ma'am feels great reading science. This way, you have to remember all of it, okay? You have to remember all of it. Yes, okay, trick was okay, I'm very happy that all of you are happy. Awesome. But you cannot forget this, okay, you have to remember. See, mineralocorticoid, when the term comes also, I know all of you will be able to remember aldosterone. Now, glucocorticoid, you have to remember cortisol, because first one is corticoids. So, sol and coids, don't get confused, okay. Cortisol, this is the most important task also. Glycogen breaks to glucose. Zona reticulosa, sex corticoid, okay. Now, I'll go back to NCERT and I'll make you read. This way, what will happen? You will be able to clearly understand and remember each and every word. Look here, let's come back to NCERT. So, what did they say? Okay, here, see here. These hormones increase alertness, pupillary dilations, piloerection, all this I understood. Now, look here. Both the hormones increases. Who? They're talking about the catecholamines. Catecholamines are who? Epinephrine and non-epinephrine, or adrenaline and non-adrenaline. Yes or no? Medulla. Medulla is one we are talking. Now, look here. Catecholamines also stimulate the breakdown of glycogen, resulting in an increased concentration of glucose. In addition, they also do lipids and proteins. So, here students can have a general confusion. Why? Because there also here, where? Here. Here under fasciculator, cortisol also is doing the same job. Catecholamines also are doing the same job. Okay, understand, many people, many hormones will do similar functions. Okay, one will be able to increase, one will be able to decrease, one will inhibit, one will promote. Like that, things will be there. So don't get yourself confused. I'll tell you why. Because see here, I'll write about the medulla. Okay, I'll write about the medulla. So adrenal medulla has two hormones. Which are the two hormones? Generally, we call it catecholamines. Okay, catecholamines. Under catecholamines, we have two of them. Okay, under catecholamines, we have two of them. That is adrenaline and noradrenaline. Or usually students, NTA will give epinephrine word, okay, because every student know adrenaline and non-adrenaline. They usually give epinephrine. I have noticed it in many of the questions as well, okay. Now, what could be confusing is that under catecholamines, they have written, okay, under catecholamines, they have written that they help in glycogen breakdown, okay, glycogen breakdown. They are going to help in proteolysis. They are going to also help in lipolysis. Just don't get this confused, okay. Rest everything is sorted, just don't get this confused. Understand, catecholamines and in your adrenal cortex, your zona fasciculata or your cortisol also will do a similar function, okay, similar function. Got it? Very nice, awesome. So glycogen breakdown is there, proteolysis is there, lipolysis is there, okay. Now adrenaline, non-adrenaline, all these people are going to be helping us for what? During the 3F moments, or act as an emergency hormone, okay, act as an emergency hormone. Yes, and what are the what are the things that you will feel when these hormones are released? You're going to feel things like pupil dilation is going to be the first one. Okay, your pupils will dilate. Then what is going to happen, students? Your heartbeat is going to increase. Okay, your blood pressure will increase actually. Okay, BP will increase. You will have low erection, okay. Then what you'll have? Sweating, okay. These are things that you will notice when these people are getting released, okay. When these people are getting released, these are the things that you will notice. Got it? Okay, heartbeat will increase, BP will increase, piloerection, sweating, pupil dilation, all this you will notice, okay. All this you will notice, okay. Now we'll go back to NCERT. Any doubts? Chalo, look here. They are called as emergency hormones or hormones of fight. These hormones bring all this to you, and also they help in the breakdown of glycogen, lipids and proteins. Now coming to adrenal cortex. So remember what I taught you. Remember Gopika ma'am feels great reading science. Remember that and try to listen to this. Look here. The adrenal cortex can be divided into 3 layers. Okay. We start with the innermost layer. Okay. So it will go R, F, G. Ulta. GFR is outermost to innermost. this one is ulta, okay, like how you had pad and dap, like that you have to remember, okay, layers of your cranium. Now look here, zona reticulosa inner layer, zona fasciculata middle layer, zona glomerulosa outer layer. The adrenal cortex secrete many hormones, yes or no, commonly called as corticoids. So all generally they are called as corticoids, all generally they are called as catecholamines, okay. Now the corticoids which are involved in the carbohydrate metabolism are called as glucocorticoid, that is your cortisol, okay. Main glucocorticoid is cortisol. In our body, cortisol is the main glucocorticoid, understood? Yes, chalo. Corticoids which regulate the balance of water electrolytes in our body are called as mineralocorticoids, that is your aldosterone, okay. Aldosterone is the main mineralocorticoids. Now look here, glucocorticoids, okay, glucocorticoids, that is your cortisol, is going to stimulate glyconeogenesis, okay, gluconeogenesis, lipolysis and proteolysis, lipolysis as well as your proteolysis, okay, and inhibit cellular uptake, okay, inhibit cellular uptake. Now, and utilization of, students, glyconeogenesis, gluconeogenesis means what? Formation of new glucose molecules, yes or no? Formation of or forming new glucose molecules from glycogen, okay, don't get it confused, same thing, glycogen gets broke down to glucose, okay. Gluconeogenesis, all the definitions I have written in one sheet, I'll teach you that. Now look here, and utilization of amino acids, so they are going to utilize the amino acid and they are going to inhibit the cellular uptake because they want the glucose level to increase in the blood, okay, chalo. Now cortisol is also maintained, okay, cortisol is also involved in maintaining the cardiovascular system, this also I told you, right, I told you, it is going to increase the cardiovascular system as well as it is going to help the kidney, okay, kidney functions. Now glucocorticoids, particularly cortisol, produces anti-inflammatory reaction, this also I mentioned, okay, anti-inflammatory reaction, and it's going to suppress the immune response, okay. I will not tell you that remember every single word, but remember these things are important, okay, these things are important, that is your gluconeogenesis or glycogen breaking down to formation of glucose, then your protein breakdown, lipid breakdown, it will inhibit cellular intake, okay, it helps in anti-inflammatory, suppress immune response, all that you will automatically remember it, okay. Now look here, cortisol stimulate RBC production, so they will also help in RBC production as well. Now aldosterone acts mainly as a renal tubule, okay, acts at the renal tubule, you know RAAS mechanism, right, renal tubules, and stimulate the reabsorption of sodium and water, this we already wrote, yes or no, reabsorption of sodium and water. And excretion, see, excretion of potassium and phosphate ions. So this you have to remember, this is a new information for you, that whenever they are reabsorbing sodium, they are going to throw out potassium and phosphate, okay, potassium and phosphate. Thus aldosterone helps in the maintenance of electrolyte body fluid volume. Students, this is very important, I have seen so many PYQs asking which is the hormone that will stimulate or balance the blood pressure and the blood volume, okay, your answer should be aldosterone. So aldosterone helps in the maintenance of electrolyte body fluid volume, osmotic pressure and blood pressure. So these two words they will give and they will ask you which is the hormone, okay, and students will write whichever hormones come to their mouth, you shouldn't write that, you should write aldosterone. Now small amounts of androgenic steroids are also secreted by the adrenal cortex, which play a, see, this is what I told you, sex, okay, pubic hair, facial hair during puberty, okay, puberty. So small amount of sex corticoids also are released by your zona reticularis, which is the innermost layer, that will help in the growth of the pubic hair, okay, normal facial hair and other things. Done. Any doubts now? See, wasn't this helpful? Right, this was helpful. So once like this notes is made, no, then reading NCERT will be like a cakewalk. If you don't, like you haven't listened to any lecture and directly you start with NCERT, then you will not find it easy at all, okay, let me tell you that it will not be easy. Okay, this is done, this is also done, okay, this also we understood. Now we are going to pancreas, okay, pancreas. All of you drink some water by then, okay. Students, I wanted to tell one thing which I forgot. This fellow, no, who tell, cortisol is in the control of ACTH, okay, is in the control, let's say this one is in the control of ACTH, that is adrenal corticotropic hormone, okay. This will control this regulation, this one is in the control of RAAS mechanism, this one is very minimal amount, okay. So this you just remember. Chalo, pancreas, before pancreas, all of you drink water. Any doubts so far? Ma'am, okay. Thank you. Now, students, before we go to this one, we had spoke about, oh, we have to write about one more thing, no? What do we have to write? I don't want the black screen. Okay, no problem. Students, we have to write about disorder. Disorder question will come, no? Yes or no? Disorder question will come. So, how can we forget disorder question? So, disorders, okay, of your adrenal, okay, anything under secretion, over secretion, anything happen. So, here they have already given in your textbook is underproduction. Yes or no? They have given underproduction will lead to what disease? Addison's disease. Okay, underproduction will lead to Addison's disease. Yes or no? Any doubts? Yes. Chalo, okay. What could be the symptoms, students? You will have weight loss. Okay, weight loss. You will be very lethargic or you will feel fatigue. Okay, you will have weakness. Okay, all this will be your general symptoms. Did I write the spelling? Yeah, Addison's disease. Okay, Addison's, not addition. Addison's disease. Okay, weight loss will be there, muscle loss will be there. Muscle loss I didn't write. Huh? Okay, you will have weak muscles. That is what they meant. Okay, muscles will be weak. Next one, students, is called as Cushing syndrome. Okay, some people tell Cushing, some people tell Cushing, some people tell, okay, many different British pronunciation is there, American pronunciation is there, but look at the spelling. Okay, we tell so this syndrome is because of excess, okay, excess of cortisol. Excess of what? Cortisol. When excess cortisol get released, this is the syndrome that you can go through. Okay, what will happen, students, when the syndrome happen? Again, you will have weight gain, you will have high blood pressure, you will have rashes on your face, you know, like a very stubborn rashes. Okay, stubborn red rashes you will have. So I'll write few of them. Okay, few of them. Weight gain, high BP you will have. Okay, high blood pressure, then you will have rashes. Okay, stubborn rashes you will have. These are some of the symptoms. Okay, this can also be because of, see, when cortisol is getting released, again this can also happen because of fall of your potassium ions as well, sodium ions as well. Okay, yes, these two diseases you please remember, Addison's disease and Cushing syndrome. Okay, done all of you? Chalo, very good. Okay, awesome, awesome. Students, how this, okay, yeah, very, no, don't get confused with your rashes. Okay, this will be, this rashes are very, it will be on the face. Okay, we also call it as ruddy face. Okay, this is not your normal rashes that you get normally because you itched something, not like that. Okay, these are going to be different, and you will also have excess hair growth. All this will be there as a symptom. Now, students, this is also can be caused. Okay, it could also be because there is a tumor. Okay, because there could be a tumor in your adrenal cortex. Okay, it could be because of a tumor that has grown in your adrenal cortex. Okay, a tumor can also cause any kind of syndrome as well. Done? Okay, this also done. So everything we have written. Now we will go to NCERT, pancreas. Ready? Pancreas. So pancreas and adrenal gland, only little more explanation is there. Other everything, testis, ovary and all is very baby. Only pancreas and adrenal gland, if you give a little concentration, you will be able to understand. Okay, I hope adrenal gland is super duper clear. Now we will go to pancreas. Now look here, students, pancreas is a composite gland. What is composite gland? That means it has both exocrine as well as endocrine activity. Agreed, all of you? I had already taught you this. So it has both exo and endo activity, okay, exo and endocrine activity. But there is one shocking thing that you will get to know, that endocrine, how much endocrine pancreas will have is only 1 to 2%. Okay, 1 to 2%. Now, ma'am, how are you telling 1 to 2%? Because the entire islets of Langerhans will be around 1 million to 2 million. Okay, that is only going to constitute 1 to 2 million. I mean 1 to 2%. Okay, 1 to 2% of the entire pancreas. So endocrine is actually less, exocrine activity is more. Okay, now students, which act both exocrine and endocrine. The endocrine pancreas consists of, see, look here, consists of islets of Langerhans. So how much islets of Langerhans is there? That will be the percentage. Yes or no? Simple. Yes, Sony is already telling it. Now, how much you people are giving concentration, that depends on how much you are listening to the class, how much you like everything, right? Totally depends on that. Okay, students, why students are not attending the class? Yeah, is it because of the morning timing? Okay, many students are missing. Chalo. Okay, so that is the reason. Understood? So how much islets of Langerhans is there? That much only your endocrine gland will be there. So islets of Langerhans is normally 1 to 2 million, because of which 1 to 2% only will be there. Okay, now they are about 1 to 2 million. Okay, 1 to 2 million of islets of Langerhans in a normal human pancreas, representing only 1 to 2% of the pancreatic tissue. Clear? Clear? Now, the two main types of cells in the islets of Langerhans are your alpha cells, beta cells. One more cell is there, delta cell. Okay, this delta cell releases somatostatin, which I taught you in the starting of the class. Okay, somatostatin, all of you remember, that is the one who will inhibit the growth hormone. Got it? So beta cells is also important, but in this, main job is going to be done by alpha and beta cells. Okay, one is going to give glucagon, one is insulin. So glucose balance will be done by these people. Okay, alpha and beta cells. Now, the alpha cells secrete a hormone called glucagon, where beta cells secrete insulin. Okay, insulin. Got it? One will release glucagon, one will release insulin. Now, what are they going to do? Let's see. Glucagon, students, is a peptide hormone. Okay, peptide hormone, and plays an important role in maintaining the normal blood glucose level. Glucagon acts mainly on the liver cells and your adipocyte cells. Okay, liver cells and, okay, here they have not mentioned. No, they have not mentioned. No, students, it acts on both hepatocytes as well as your adipocytes. Where did you study adipocytes? 1 to 2%. Hey, you only told the answer and you are only asking me. 1 to 2% means how much endocrine activity do the pancreas have. So pancreas endocrine part is your islets of Langerhans. Okay, those are the cells. Islets of Langerhans is only 1 to 2 million. Okay, islets of Langerhans is only 1 to 2 million. Chemistry class, where chemistry class is happening? In DNA batch. Yes, where is chemistry class happening? Is it happening on our channel or some other channel? Not here, no? Diksha ma'am is not taking class here, no? DNA. Okay. So, what they are going to do? So, this 1 to 2% is because of how much islets of Langerhans is there. Okay. Got it. Now, students, with the hepatocyte cell, they are also going to adipocytes. Because why adipocytes? Because we learned it, no, that whatever glucose is there, the rest they will store it and keep it. Right, that's rest they will store and keep. Oh, DNA, okay, okay. So, they will stimulate glyconeolysis, okay, that is breakdown of glycogen. Lysis means breakdown, okay, resulting in an increased blood sugar level that will be called as hyperglycemic condition. In addition, this hormone stimulates the process of gluconeogenesis, that is formation of glucose, okay, formation of glucose, which also contributes to hyperglycemia. Now you will be like, huh, this fellow told that he is going to do glucose balance and he is doing something by himself. Okay, he is doing something by himself. No, different story. Why? Because I told you, last class also I told you, one should increase, like your parathyroid and your TCT, one should increase the calcium level, one should decrease the calcium level, because that is how balance will happen. Okay, that is how balance will happen. Got it? Okay, next one. Look here, glucagon reduces the cellular glucose uptake and utilization, thus glucagon is a hyperglycemic hormone. Okay, what they were trying to say, students, very simple, let's go here. Okay, let's glow. Okay, let's go here. So what they were telling here, they were telling that let's write here glucagon. What is the job of this fellow? Okay, who is releasing this? All this is very, very important. See, now if I draw islets of Langerhans, okay, these are the set of cells. Okay, these are the set of cells, islets of Langerhans. Now in this, let's draw one color all the cells. So this is islets of Langerhans. How much will be there? 1 to 2 million will be there. Okay. Now in this only 3 cells are going to be there. Which are the 3 cells? All of you in the chat. You people focus here. Don't think about chemistry class when you're in biology class. Okay. Now students, in the cells only there is going to be your alpha cell. Okay. There is going to be alpha cells. Okay, there is going to be beta cells. Okay, I am randomly drawing it, beta cells, and there is also going to be delta cells. Yes or no? There is also going to be delta cells. So this is how your islets of Langerhans will be. Okay, islets of Langerhans. Oh, I actually like that emoji. Very nice. That glow emoji is very nice actually. Should we change from fire to glow? Okay, so yes, look here students, these are the cells. If you people don't have energy, then I'll also feel like, oh, what is this class, right? So you should always have energy. Now look here, this is your alpha cell. Alpha cells. Alpha cells will release what? Glucagon. Okay. Then you have beta cells. Beta cells will release your insulin, most important cell. Okay. Most important cells. Now delta cells, students. This is delta, no? Delta cells. Delta cells will release somatostatins, okay, which will inhibit growth hormone. Okay, which will inhibit growth hormone. You guys are so sweet. Okay, whoever is here, they're very sweet. Yes. So this is clear. So this is how your islets of Langerhans will be there. So here the percentage. Let's write it here. Islets. This became more RNA CDS no students than NCERT line by line. Okay, islets of Langerhans. Okay, which will constitute 1 to 2% of your endocrine gland. Done. Okay, ma'am, clear. Ma'am, now tell us about glucagon. Glucagon's main job is to maintain the glucose level. Okay, maintain glucose level. Okay, maintain the glucose level. But what are they doing actually? They are maintaining the glucose level. No doubt they are maintaining the glucose level, but they are doing hyperglycemic condition. That is, they are increasing the glucose, right? How are they increasing the glucose, students? First, they will do breakdown. Okay, they are going to do glyconeogenesis. Okay, not breakdown, they are going to formation of new ones. They are also going to do breakdown, that is glycolysis. Right, glycolysis also they will do, that is glycogen will be broken down, and they are going to take the help of which cells? Hepatocyte cells, okay, hepatocyte cells as well as adipocyte cells, okay, adipocytes. Why they are taking the help of these cells? Because storage, right, adipocytes would have stored and kept a lot, no? So storage, for that they will use hepatocyte cell and adipocyte cell. Any doubt so far? Okay, this somatostatin is secreted by your hypothalamus as well, okay. So it is not like solely from this fellow, but it is going to. Okay, done. Glycogenolysis, glyconeogenesis. Okay, what they are going to do? Okay, these people are going to mainly act on. Okay, 1 second, I'll write it in different color. How they tell, no, bigil sorata mukyam, color is tumma mukyam. Okay, so glycogenolysis. Okay, this is breakdown, and then they mainly act on, okay, act on hepatocyte. Hepatocytes means liver cells, okay, hepatocyte cells and your adipocyte cells. adipocyte cells. Now what are they going to do? They are going to make a complete condition of hyperglycemic condition, that is increase the glucose level. Because they are going to increase the glucose level, they will inhibit the cells, okay, inhibit the cells from taking any glucose. What I was trying to say, I'll show you now, okay. They are going to make an hyperglycemic, okay, glycemic condition. Now students, you tell me this, I asked you before also. Now look here, this is the blood vessel, okay, this is the blood vessel. In this blood vessel, let's say there is lot of glucose, okay, lot of glucose, okay. These are your cells, okay, these are your cells. Now will they inhibit or promote the cellular intake? Will they inhibit or promote the cellular intake? Tell fast. Inhibit, promote. Tell fast. What are you people talking? Okay, what are you people talking? Too difficult? No, we only did one gland so far. Now one more gland, that's it. What happens to me? Tumba mukyam. Tumba is Kannada. Romba is Tamil, no? Not food, color is important. Yes, very good, very good. Those who understood will tell the answer. Those who did not understand, ask me explanation. I am ready to explain how many ever times you want. Okay, I have come here to give you the explanation. I will explain. Very good. I think everyone understood. Inhibit. Why? Because their main job is to make a hyperglycemic condition in the blood. So they will not allow, okay, they will not allow the cells to do cellular uptake. Okay, so they will inhibit, okay, inhibit cellular intake. Clear? Glycogen is clear? Okay, glucagon is clear? Yes, fine. This is the whole thing. Okay, now insulin we have to write. Before that, we'll go back to NCERT. Okay, now this is done, students. Hyperglycemic. Now look here, insulin. Okay, bits and pieces insulin is there. Insulin also is a peptide hormone which plays a major role in regulation of glucose homeostasis, that is to maintain the glucose level. Okay, to maintain the glucose level. Now insulin acts mainly on hepatocytes, again same thing here also, and adipocyte cells. Okay, adipocyte cells of the adipose tissue, and enhances the cellular glucose uptake and utilization. As a result, there is a rapid movement of glucose from the blood to the hepatocytes and the adipocytes, okay, resulting in decreased blood glucose level, that is hypoglycemic condition. Insulin also stimulates the conversion of glucose to glycogen, that is called as glycogenesis. So whenever genesis is coming, that means they are conversion, forming, okay, synthesis is happening. Whenever lysis is coming, breakdown is happening. Okay, yes, yes. Okay, now look here in the target cells. The glucose homeostasis in the blood is thus maintaining jointly by two people, insulin and glucagon. Got it? Now we will go to learning insulin. Students, before that, let's see here. What is the definition here? All of you focus here for 5 minutes. 5 minutes focus here. Don't think about anything else. Listen here. Gluconeogenesis. Neo, new. Okay, neo means always new. Okay, so gluconeogenesis means synthesis of glucose from non-carbohydrate substance. Could be proteins, could be lipids, could be fats. Okay, when we are doing a 12 hours fasting, this is what happens. The glucose will be taken from the fats, lipids and other things. Okay, so synthesis of glucose. So neogenesis means forming of something and glucose will be formed. Now glycogenesis, we are forming glycogen, that is synthesizing glycogen from glucose. Okay, that is what insulin is going to do. Insulin will be like, there is so much glucose in the blood, I will convert all of this and store it as glycogen. Got it? So here also genesis. See, genesis means we are forming something or we are synthesizing something. Whom to whom you have to remember. Okay, who asked whom? In Kannada now we have to write a lot of exams, no? Okay, so like that. Here see, glycogenesis means synthesizing glycogen from glucose. Now glycolysis. Glyco means glucose is getting converted to glycolysis. You studied in your Krebs cycle glycolysis. Okay, you studied in which chapter, students? Photosynthesis, no? No, respiration. So glycolysis, glucose to pyruvate conversion will happen. Glycogenolysis. Who will break down? Glycogen will break down to glucose 1-phosphate and glucose. Okay, so you can simply remember glycogen to glucose. Is this clear? Is this clear? So lysis means breakdown, genesis means formation, neogenesis means formation of glucose from non-carbohydrate substance, genesis means synthesizing glycogen from glucose. So genesis means something is getting synthesized, lysis means something is getting breakdown. Okay, respiration, yeah, I remember, respiration. Now students, I had to tell about this also. Okay, this is insulin is done. Now look here. This is the diagram of your pancreas, okay. So islets of Langerhans, if you see the whole thing, okay, if you see the whole pancreas, you will notice that there is one cell called as acinar cell. This cell is actually a part of the exocrine. Part of the exocrine. If you can remember, if you cannot, totally forget it, no problem. Okay, no problem, but just know this is a part of the exocrine. Now look here, alpha cells is there, glucagon, beta cells, insulin, delta cells, somatostatin, then other cells are there which you don't have to know, PP cell and all that. It is not at all important for you, but can you see how the cells are scattered? So this is your islets of Langerhans, and then you have your acinar cells around it, okay, that will be the exocrine part. This is only going to constitute 1 to 2% of the entire pancreas, okay, 1 to 2% of your entire pancreas. Now we'll write insulin. Where do we write insulin? Okay, we'll write insulin here. Can we fit here insulin, students? Can I write insulin here? I can try. I want it in one sheet itself, that's why. Okay, we'll try to fit in insulin here. Okay, let's take this challenge up of fitting insulin here. Okay, I'm drawing a line. So nothing much about insulin. Ulta you write off this. Okay, ulta of this one. Insulin. Insulin, what is it going to do? If this fellow is increasing, this fellow is going to decrease. Okay. Divya, are you okay? She is quoting some prayers. Oh hi, I miss my DNA students so much. They don't even come and tell me hi. Such bad kids they have become. Okay? I like RNA students more now, because they always tell me hi. This DNA students doesn't even come to tell hi. Tarika, pass this information to all the DNA students. Okay, they've forgotten me. Okay. Okay, jokes apart. Look here. Insulin, what is its job, students? Insulin's job is to make it hypoglycemic condition, because this fellow is going to do hyperglycemic condition. So, they are also going to maintain glucose level, but they are going to do glycogenesis, that is going to convert the glucose to glycogen. Okay, going to convert glucose to glycogen, and these people also are going to act on what is happening? Hepatocytes and adipocytes. Yes or no? These people are going to act upon them. These are released by your beta cells. Okay, beta cells is the one who is releasing your insulin. Then they are going to make a hypoglycemic, that is, they are going to do cellular intake. Okay, yes. Okay. I know, Tarika, just joke. Okay, don't worry. I'm not angry on any of my students. How can I be angry on any of my students? Okay, yes. This is the blood vessel. Sorry, Divya, I did not know that was a song. And why would you sing a song in a class? First of all. Okay, this is the glucose, students. This is the tissues. I mean, this is the cells. What they will do, they will not inhibit. They will tell you take all the glucose from the blood and you utilize them. Yes or no? They'll tell the cells to utilize. So they will promote cellular intake. Promote cellular intake. Got it, all of you? Yes or no? These will form an hypoglycemic condition. Hypoglycemic condition. Clear? All the singers have come. Exactly. Divya, raise your hands and stand for 5 minutes. You know, if it was your maths teacher, no, if you were singing song or if you were, you know, doing this in the class, what she will tell? Come front, stand here and sing. Let all of us get entertained, no? Since I am on YouTube, you people got saved. If I was in your offline class, I would have called you people front and I would have told, come sing for everyone. Okay? And if you're laughing, what I would have told? Why only you're laughing? Let all of us laugh, right? We need longer life. So they tell, no, if you laugh a lot, your lifespan will increase. So I would have told, come front, make all of our lifespan increase. Okay, I would have done that. But you're lucky enough that I'm not your offline teacher. Okay? You can ask my offline students. They'll not even look like this. They'll be like, ma'am will catch. So what happens when you're in, especially when you're in girls' college, girls have a very high tendency that if their friend has left the hair like this, they'll keep plaiting the hair. I think all of you know, no? They'll keep plaiting the hair, no? So the students used to plait the hair, okay? So when the first time when I went, so see, we all know it. I'm not like an ancestral property that I was born in, you know, in 1947 or something. I know I'm very new to this, like I am just very, few years back I was out of college. So I know what and all the students will do, okay? So this, okay, this students used to plait hair. So whenever I come, no, suddenly they'll keep their hands like this. They'll be like, let's not plait, because if they plait, I'll tell them you come front and plait everyone's hair. Okay, plait for everyone and give. So why only one person should look fashionable and beautiful in the class? Everyone should look, okay? You do French braid, you do whatever braid, you come in the front and do. So they used to not do it anymore. Yeah. So but yeah, good talent, Divya. You're able to remember the lyrics and sing it. Very nice. Okay. Sumi, nothing is happening to you today. All your hormones are working properly. Now listen to the class, okay? All of you back to the class. Chumma 5 minutes they'll ask. What is happening to me? What is happening to you? Nothing is happening. You have to study. When your brain starts working, problems will start happening. Now listen to the class. Okay. So here, glucagon done. Maintain the glucose level. Gluconeogenesis. Glycogenolysis. So here you can see, here it is genesis. That means they are synthesizing glucose. Okay. Synthesizing glucose. I am not writing it again here because next page I have written that, okay. Acts on hepatocytes and adipose tissue. Here also same thing is going to happen. This will be adipose tissue. They will act on adipose tissue, okay. Adipose tissue and liver cells. Adipose tissue and liver cells. Got it? Okay, back to class. Yes, very good. Okay. Now they will make sure that the cellular intake will happen. Done? Okay, pancreas is done. Any doubts, students? Now here we have condition, no? Diabetes mellitus. That is, prolonged hyperglycemia leads to a complex disorder called as diabetes mellitus. That is, when the insulin is not doing the function or insulin is not able to do the function, what is going to happen? Insulin will, like the hyperglycemic condition will keep increasing, okay. Okay, hyperglycemic condition will keep increasing. That is, the glucose level in the blood will keep increasing and insulin is not telling anything, insulin is not doing anything, insulin is not telling the cell to utilize the glucose. So what will happen? We will get a condition called as diabetes mellitus. Okay, diabetes mellitus. Okay, so which is associated with the loss of glucose through urine, okay, urine and formation of harmful components called as your ketone bodies. Okay, ketonuria, all of you remember, no, we had studied it in excretion chapter, where your ketone bodies will be formed. Not only that, many acetates will be formed, other many things will be formed which is not necessary for your body. So diabetes mellitus will be problematic. So diabetes mellitus, diabetic patients are successfully treated with insulin therapy. So insulin should be there, glucagon should be there, otherwise you feel, no, that low sugar level happened, like people cut down all the kinds of sugar and then they'll feel like no rice also, no carbohydrates. Like when they do this, you know, starving for a very longer time, why do they feel dizzy? Why do they feel like, okay, they will fall down? That is because insulin is not there. From where will glucose be made? Okay, from where will glucose be made? Something should be stored, no? That storage also won't be there. Okay, so always have your meals properly, right? Proper time. I'm only telling. Who is telling, you see? Okay, a person who never has proper meals is telling. Yeah, so diabetes mellitus is clear, no? Diabetes mellitus is clear? Okay, students, we'll just take a 10 minutes break and come back. Not lunch break or anything, normal, just a, you know, coffee break type. We will just take a 10-15 minutes break and come back, okay? I'll be back soon. Because after that, we'll finish off the chapter. There's nothing left. Very small portion is left. Okay? You tell me what time? All of you tell me what time? Yes, ketonuria, very good. Glucose Surya. Then after some time, glucose Vijay. Okay? Then Talapati, one name will come. Tell me how much, what's the time? Yeah, 40 already. Okay. So fast time goes with you people. Teaching, I will not even know. Okay, 55. Okay, 12:55, 15 minutes, yeah. all here? Okay, ready for next topic? Okay, now we have testis, ovary, additional organs like your heart, JG cells, kidney and your gastrointestinal tract. Those are there. After that we have mechanism. Okay, yes. Testis, a pair of testis, so we all know this, a pair of testis is present in the scrotum or the scrotal sac. Why? To maintain the temperature or to reduce the temperature by 2 to 3 degree, okay, 2 to 3 degree from the body. So a scrotal sac, okay, outside the abdomen of the male individual. Testes perform dual functions as they act as a primary sex organs. Why we call them a primary sex organs? Because they are obviously forming the gametes, right? They are helping in the formation of the gametes. So they are the primary sex organ. At the same time, the androgens, that is the testosterone, is released, which will help them in all the secondary sexual characters. So look here. Testes perform dual functions as a primary sex organ, okay, as a primary sex organ, as well as an endocrine gland, okay, as well as an endocrine gland. Now, here, testis is composed of seminiferous tubules as well as stromal or interstitial cells. The Leydig cells or the interstitial cells which are present in the intertubulary spaces produce a group of hormones called as androgens. Okay, so the Leydig cells or your interstitial cells forms your testosterone. Androgen means testosterone is a type of an androgen. Okay, now androgen regulates the development, maturation and function of the male accessory sex organs like your epididymis, okay, vasa deferens, seminal vesicle, what is that? Okay, seminal vesicle, prostate gland and urethra, etc. So they also help in the male accessory organs, development of the male accessory organs. They also help in the secondary sexual character, be it the building of the muscle, be it the protein catabolism, all of that they are going to help. Okay, these hormones stimulate muscular growth, growth of the facial, axillary hair, aggressiveness, low pitch voice. Okay, so these are the things. No, now all of you know, when you see the boys, right, after they reach puberty, when they reach puberty, you will notice that they will have a low pitch, a very bass kind of a voice. At the same time, they will be angry, aggressiveness will be there, muscle building will be there, facial hair will be there. All this will be developed by your androgens, testosterone, okay. Low pitch voice. Androgens play a major stimulatory role in the process of spermatogenesis, that is formation of your spermatozoa. Now, you have already studied human reproduction, so this chapter, I mean, this topic will be very easy for you, but usually how does it go? Finishing all the 11th portion, we go to the 12th portion. No? So, student who is studying newly, first time the 11th portion, it will be little difficult to understand. But since you have already studied human reproduction on this channel with Basva sir, these topics will be very baby for you. Like, ma'am, I already know it, okay? Now, look here. Androgens act on the central neural system and influence the male sexual behaviors. That is called, male sexual behaviors is called your libido. Okay, these hormones produce anabolics, okay, anabolic effect, sorry, I told catabolic by mistake, anabolic effect, that means formation, okay, catabolism means breaking, anabolism means formation, okay, formation of protein and carbohydrate metabolism. So students, what did they say? They are telling about testis, okay. Did we use a lot of this color today? Color, which color do we choose? Okay. So, they are telling that testis, okay, is present inside the scrotum, okay, scrotum. What is the use of scrotum? To decrease the temperature, right? Decrease or reduce the temperature, okay, decrease or reduce the temperature 2 to 3 degrees, okay, 2 to 3 degrees from the body temperature, okay, compared to the body temperature. Okay, now they are telling that testis, okay, they are telling that testis is acting as the primary sex organ. Two dual functions they are doing, okay, Okay, dual functions. Those who joined right now, I want all of you to smash that like button. Okay, mark your attendance. It's very, very, very important. Wow, students, wait. There's so much glow emoji. So beautiful, so pretty it is. It looks like those firecrackers, no? I actually like it. Okay, yes, all of you mark your attendance. I cannot see the attendance at all. Conjuice, number one you people have become. Okay, so dual function. First thing is it is going to act as a primary sex organ. Okay, primary sex organ. Second thing what it is going to do, it is also going to act as an endocrine gland. Okay, endocrine gland. Now primary sex organ, why students? Because obviously it is forming the sperm, right? It is going to help in the formation of the gamete. Okay, formation of gamete. Then here what is it happening then? Endocrine gland is going to help in the release of an androgen, and that androgen or the hormone is none other than testosterone. Okay, testosterone. Now this testosterone is not a very simple fellow because it is going to help in so many other things, like what? Testosterone is going to help in the growth of your male accessory organs. Okay, accessory organs. Who are the accessory organs? Like your epididymis, okay, prostate gland, vasa deferens, urethra, etc, etc. Okay, they are going to do this. Then they are also going to do, okay, first I light about this one, okay, low pitch voice, aggressiveness, okay, facial hair, all of that, okay, facial hair, etc. So all these things they are going to do, yes or no, right? Now they are telling, okay, this who tell androgen is released by your interstitial cells. Is this clear, students? Any doubt? Facial hair, aggressiveness, low pitch voice, all the male, you know, secondary sexual characters, okay, all the secondary sexual characters, even their behavior also will be modified, okay, because of the release of this, okay, because of the release of this. Is this clear? Yes, yeah, beard and all will start coming, okay, beard and all will start coming. Yes, the Leydig cells or the interstitial cells. Any doubt in this? Any doubt in this? All of you in the chats, you tell me, okay. I'm writing same lines of NCERT, okay, nothing outside, just same lines of NCERT. So this is very important, dual function primary sex organ, that is the formation of the gamete, okay, sperm has been formed, spermatogenesis, so it is going to help in spermatogenesis. At the same time we have endocrine gland, even the androgen, testosterone also is going to help in spermatogenesis as well, okay. Now testosterone is going to help in the growth or the development of the male accessory organs like your epididymis, prostate gland, vasa deferens, seminal vesicle, all of this, okay. Then at the same time it is going to help in the you know, changes that will happen to a person, okay. And very, very importantly, students, we didn't write that, anabolism, okay, anabolic of protein, okay, protein and carbohydrates, that is formation, okay, formation. Anabolic nature means formation, catabolism means breaking down, okay. So yes, very good, someone told already, yes, produce the effects on protein and carbohydrate synthesis as well. So formation of that also happens, muscle building will happen, low pitch voice, aggressiveness, all this, growth of the facial hair, all these characters are done by your androgen or your testosterone, okay, testosterone. So students, this is the whole thing about testes, nothing much you have to know, you already know from reproduction chapter, you will study in depth in reproduction chapter, and now you have already studied, so this is going to be very easy for you, okay, very easy for you. Now we'll go to ovary, okay, ovary. Now students, look here, female have a pair of ovaries, okay, located in the abdomen. Okay. Ovaries is the primary female sex organ which produces one ovum during each menstrual cycle, right? Every month one ovum will be formed, and if fertilization does not happen, that ovum with the endometrium lining will shed to form the periods or your menstruation, right? Now they are telling the same thing. So primary sex organ means what? Ovaries are again acting as a primary sex organ at the same time as an endocrine gland. That is, they are releasing the hormone, at the same time they are also forming ovum for fertilization. Okay. So they produces one ovum during each menstrual cycle. In addition, ovaries also produce two groups of steroid hormones. See, steroid word has come. All this while we came across peptide word, right? Here you can see steroid hormone. So next topic will be mechanism of hormones. In mechanism of hormones, you will understand, depending on the type of hormone and depending on the nature of the hormone, how they are going to react with our body. Okay, how they are going to react with our body. So steroid hormones called estrogen and progesterone. Okay, progesterone. Now ovary is composed of ovarian follicles and the stromal tissues. The estrogen is synthesized and secreted mainly by the growing ovarian follicles. Okay, so follicles are the one who is going to release the estrogen. Okay, now after ovulation, the ruptured follicle will be converted to a structure called as the corpus luteum, which secretes mainly progesterone as well as your relaxin. Okay, two things it will be forming. Now estrogen produce wide-ranging actions such as stimulation of the growth and activities of the female secondary sexual characters, developing of the growing ovarian follicles, appearance of the female secondary sexual characters like your high-pitched voice. Okay, high-pitched voice. Now mammary glands development. Estrogen also regulates the female sexual. Same thing like men. Okay, same thing. Secondary sexual characters will be there. At the same time, they also help in other things. Okay. Progesterone supports pregnancy. Progesterone also act on the mammary glands and stimulate the formation of alveoli. That is the alveoli, not the lungs alveoli. Okay, mammary alveoli will be then a sac-like structure which can store the milk and help for milk secretion. Okay, milk secretion. One second, students. Oh, ho, 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 ho. Oh, ho, ho, oh, ho, ho. Yes. Oh, come. Sorry. Yes. Okay. Got it. Now, let's write about ovary. Okay, ovary. Students, here they are telling about ovaries. Okay, what did they tell? This is also same thing, that they are present, okay, in the abdomen in females. Now what did they tell? This also has two functions, right? They are going to have dual functions. First thing is they are going to act as the primary sex organ. Okay, they are going to act as the primary sex organ. And they are also going to help in the release of what? Two steroid hormones, right? They are going to help in the release of two steroid hormones, 1 and 2. Okay, what is it? Estrogen and progesterone. Okay, progesterone. Now students, normally if you see your okay, this one looks fine, no? Yeah. Now I've never taught you people reproduction chapter, I know, but yeah, listen here. Your follicles, right? Follicles. Now if you see here, these are your follicles, yes or no? Yes. Why is the chat so slow? Since come on, yeah, people, you should make the chats more. 1 second. Draw it a little more small. Okay, primary, secondary, tertiary, and your graphene follicle. So students, from primary, right? So your primary, secondary, tertiary, and this becomes your graphene follicle. Okay, graphene follicle. So how is this growth happening, right? How is this growth happening? This growth is happening because of the use of your FSH. Agreed, all of you? FSH is the reason for the follicular growth. Okay, FSH is helping. Here also FSH is helping for the growth. Now these follicles, be your primary, secondary, these follicles are going to give out your estrogen. Yes or no? These follicles are going to give you estrogen. Now these follicles are going to mature and form graphene follicle, and here obviously ovulation and other things will happen. Okay, ovulation will happen. Now students, this graphene follicle, the rest of it will form corpus luteum, right? Corpus luteum, which is an yellow color. Okay, corpus luteum will be formed. This corpus luteum is the one who is going to form, okay, who is going to form your progesterone. Okay, who is going to form the progesterone. And this progesterone is the one who is going to maintain the pregnancy. Maintain the pregnancy. Yes or no? Yes. Can you see the diagram and understand? Graphene follicle. All of you? Now, so in between this, obviously graphene follicle, here LH is going to help for the ovulation to happen, right? LH is going to help. So that I'm writing it here as well. LH, luteinizing hormone. Till that FSH was helping, the follicles is going to release estrogen. After that the graphene follicle is there. After that ovulation will happen. The rest of it will become corpus luteum, and the corpus luteum will form progesterone. Progesterone is the one who is going to maintain the pregnancy. Okay, maintain the pregnancy. Got it? This is important because many students will misunderstand. It is estrogen, right? Estrogen also to a little amount is there, but maintaining the pregnancy will be done by progesterone. The endometrium lining, everything will be maintained by your progesterone. At the same time, your ovaries are also forming relaxin. Especially your corpus luteum is going to form relaxin. Okay, this is to help the muscles, right, to soften the muscles. So these things are done by who? Your corpus luteum. Okay, corpus luteum. So I'll write it here. Corpus luteum. Now students, they are going to help in all the characters, right? Be it low pitch voice, be it growth of the secondary sexual characters, all these characters these people are going to take care. Now under progesterone, always remember they maintain the pregnancy. Any doubts so far, students? Any doubts? Any doubts? Ask me right now. Yes. Got it? So here, okay, follicles are secreting estrogen, especially your graphene follicle is the one who is going to mainly help in the secretion of estrogen. Okay, mainly going to help in the secretion of estrogen, and this estrogen is not a simple fellow, because why? This is going to help with all the secondary sexual characters. Okay, all the secondary sexual characters will be taken care by your estrogen, and progesterone is going to maintain the pregnancy, and this is released by the corpus luteum, as well as they are going to release relaxin in the later stages of the pregnancy. That means when parturition has to happen, they will make sure that the ligaments, everything softens, so parturition will happen. Okay, at the same time, something else I wanted to tell. Yeah, progesterone will maintain the pregnancy, at the same time maintain the endometrium lining, and if progesterone is less, definitely fertilization has not happened, then your menstrual cycle as normal it will happen. Okay, now estrogen will do the growth of all the secondary sexual character, growth of your the voice modulation, all of that will be taken care by estrogen. So understand the difference between both of them, because two steroid hormones are there are chances that you mix up and write everything. Okay, instead of that, make sure that you understand. Okay, all of you? Yes. At the same time, what is mentioned in your NCERT? Formation of your alveoli, right? Alveoli will be formed so that milk secretion also happens. Okay, milk secretion happens. Yes, students, everything is done. So this is what you already know. Okay, this is what you already know. So this is about your ovaries. Now we'll go to hormones. Other hormones, that is, now we have completed all the organized endocrine glands. Okay, starting from, you start from your head. Okay, hypothalamus, that is the principle, leave it there. Start from your pituitary, pineal gland, your thymus, thyroid. Okay, thyroid, thymus, down you come, kidney, adrenal gland, testis, ovary. We have completed. Now other than the organized endocrine gland, there are some additional glands which are helping us for some functions, like your heart, which releases atrial natriuretic factor. We have kidney that releases JG cells, again renin and all that. Liver is there, which will release angiotensinogen. So at the one stage of life, or at one stage or one process, these people are also acting and helping us. Okay, that is what we are going to learn. So look here, now you know about the endocrine glands and their hormones. However, as mentioned earlier, hormones are secreted by some tissues which are not endocrine glands. So this was the question which was asked for one of the PYQs. They had given all the organized gland, with that they had added liver also. Okay, and the students were asked if the assertion reasoning is true. So you have to be careful when you go through the endocrine gland. Make sure that the word, if they have given organized endocrine gland, only go for the ones that we learned now. Okay, now if you learn like otherwise, okay, if you learn like these, they are tissues, or they are not well organized endocrine glands, but they're still helping us in release of something. For example, the atrial walls of our heart secretes a very important peptide hormone, okay, called as atrial natriuretic factor. Students, ANF, where have we studied? ANF, where have we studied? All of you in the chats, where have we studied ANF? Quickly tell me. The only mixed glands are your PG, that is your pancreas and the gonads. Okay, gonads. Okay, other things are all endocrine glands. Now look here students, ANF we have studied in the excretion chapter, right? The mechanism. ANF works antagonistic to RAAS mechanism. That is, if RAAS mechanism is trying to increase the blood volume, increase the sodium absorption, ANF will do the opposite. So this way the balance will be there. Okay, so this one will do diuresis as well as natriuretic, that is ulta. Like they will be like losing all the water and the sodium ions, but RAAS mechanism will be absorbing all of it. This is to maintain the balance. Okay, this is secreted by the atrial walls of the heart, which is not a proper endocrine gland, it's just a group of tissues. So here, which decreases the blood pressure. When the blood pressure is increased, okay, ANF is secreted, which causes dilation of the blood vessels. This reduces the blood pressure. This reduces the blood pressure. Okay, so after this, we have to write few things. So here only write about ANF. Okay, here only write about ANF. So students, ANF full form, very, very important. Okay, they'll ask you the full form. ANF. What is it? Atrial natriuretic factor. How is it going to work? It's going to work antagonistic in nature. It's going to simply, we can write opposite to RAAS mechanism. Okay, opposite to RAAS mechanism. See, you can understand now how all the human physiology chapters are connected with each other. Everything is connected to each other, right? Okay. Yes, now look here. Oh, spelling, I'll faint off now. Opposite to RAAS mechanism. So this one, see, this is not like purposely doing it. Why is it doing it? Because the blood pressure has increased, blood volume has increased. So when the condition increases, when does RAAS mechanism get switched on, and when does RAAS mechanism work? When everything is decreased, right? Here when everything is increased. So this is going to work when the BP is high, okay, blood volume is high. I've told you the problems, remember? In excretion chapter, I had taught you all the problems and the solutions for it. Blood volume is high. During this time, these people are going to work and they are going to make sure that there is, you know, loss of sodium ions, okay, and then there is loss of water. Loss of water. This will be diuresis. This they will do to maintain the balance, okay, so this is mainly done to decrease the blood pressure. Decrease the blood pressure. This is what ANF does, okay? And this is very important. You have to write it is released, okay? It is released. Secreted is a bit better word. Secreted by atrial walls of heart, which is a tissue, not a pure endocrine gland, okay? Endocrine gland. Done? Yes, all of you? Histamine is going to help during the allergic reaction. It is going to do vasodilation, so more blood can flow and you can show inflammation. Okay, inflammation, like you can see the redness. If you don't see the redness, how will you know that an allergic reaction has happened, right? So it is going to do vasodilation. Got it? Vasoconstriction, your serotonin will do. And then you have, what else you have? Albumin, osmotic balance, fibrinogen for coagulation. Okay, heparin, anticoagulant. Only this 5 you have to remember. Okay, chalo. Now students, here very very important, we are going to study the rest of it. Okay, look here, the juxtaglomerular cells, we already know kidney. Yes or no? We'll write it here only, no? Oh, I utilized the entire board. Now where do I write it? Okay, let's draw a box here and write it. Students, who doesn't remember this? Who doesn't remember that JG cells releases a protein called as erythropoietin? Erythropoietin that does erythropoiesis. What is erythropoiesis? I told you people, erythropoiesis is the formation of RBCs. Okay, formation of red blood cells. Okay, formation of RBCs. Cortisol also is going to help in formation of RBCs. Got it? Yes. Understood? JG cells is your juxtaglomerular cells which are present, right? We all learn juxtaglomerular cells. So students, here it's a peptide hormone called as erythropoietin, which is going to help in stimulating erythropoiesis, that is formation of your RBC. Done, done, done. Now here listen carefully. From here you have to listen carefully. Questions will come from here. Endocrine cells present in different parts of the gastrointestinal tract secrete 4 major peptide hormones, namely gastrin, secretin, cholecytokinin, CCK, PZ actually, gastric inhibitory peptide, GIP. Okay, so these are the ones that are secreted by your gastric, okay, secreted by your gastrointestinal tract. Gastrin acts on gastric glands and stimulate the secretion of hydrochloric acid and pepsinogen. Secretin acts on exocrine pancreas and stimulate the secretion of water and bicarbonate ions. Okay, but this fellow also does the job of inhibiting gastric mobility. I'll make you write a box, you learn that box only. Okay, I'll make you write a box, you learn that box alone. Yes, okay, so here pancreas and secretion of water and bicarbonates. CCK acts on both pancreas as well as gallbladder and stimulate the secretion of pancreatic enzyme and bile juice. So the full name is CCK-PZ, that is pancreomycin. Okay, that is because it releases an enzyme. Okay, pancreomycin. If you can remember that, it is easy because you will be able to connect with pancreatic and enzyme. Okay, so what are they going to do, students? CCK acts on both pancreas and gallbladder and stimulate the secretion of bile. Okay, pancreatic enzymes and bile juices respectively. GIP inhibits, okay, this fellow is going to inhibit gastric secretion and mobility. Okay, even that secretin also was going to inhibit, even though the name is secretin, which was supposed to secrete, it went for inhibition. Okay, some people, we look at them and we tell, no, yo, looks like this and actions are like this. We compare and tell, no, like that this fellow is secreted. And several other non-endocrine tissues secrete hormones called growth factors. These factors are essential for normal growth of the tissue and repairing and regeneration. Now here you have to write this. It is important. Okay, important. Ready? All of you? All of you ready, ready, ready? No, no ma'am, never ready. Students, actually there is a there's a tabular column in your Tatva. Okay, tabular column in your Tatva. I will send you a photo of it on my WhatsApp channel. Okay, I'll send a photo on the WhatsApp channel. Okay, ready all of you? I don't know where all my students have ran away. None of them I can see. I can see more Nika than my students. One second. Yes. Okay. Start? Okay. Now look here. Hormones secreted from function. I have not written the target. Okay, I have not written the target. I'll tell you guys the target. Look here. Gastrin, students, is secreted from the stomach. Okay, from the name only you will understand. No, it is secreted from the stomach. Your CCK is secreted from the intestine. Okay, this also intestine. This also intestine. Okay, intestine. What is wrong with intestine? Okay, intestine. These are secreted from these places. Got it? Their target organs will be stomach, like CCK for stomach. So target organs I'll tell you later. Yes. Now here you are going to write the functions. Okay, what are the functions, students? Go one by one. First, gastrin. Gastrin's main function was to release hydrochloric acid and pepsinogen. At the same time, it also promotes your gastric mobility. Okay, promotes gastric mobility. So here we'll try to fit in everything possible. I made the box little small here. So it will stimulate production of pepsinogen and HCl. Okay, HCl. This I'm making only for you. I could have just underlined and gone, but that will not help you. Okay, this should help you. HCl. And also they promote gastric motility. Not mobility, motility. Yeah, no, motility is the word given in NCERT, no? Where is the word? Motility. Okay, perfect. Now, next is CCK. I told you CCK, PZ, you remember. That is, they are going to help in the stimulate the production. I'll write it in different color. Too much, otherwise it will become. Okay. Stimulate production of pancreatic juice. Okay, pancreatic juice. Yes, and bile. And very, very important, they release. Okay, they release enzyme. Okay, they release pancreatic enzyme. Very, very important. PZ, Z for enzyme, you can remember. Okay, pancreatic enzyme. Next thing is your secretin. Job should have been secretion, but what is it going to do? First thing it is going to do is inhibit. Okay, inhibit the job of gastric motility. Okay, inhibit gastric motility. I think that they have not given here in NCERT, so we will just wipe this off. Oh no, 1 second, students. Okay, that is not given, so I am not writing it there. Okay, pancreatic. Okay, inhibit gastric mobility, but also helps in secretion of what? Secretion of what, all of you in the chats? It's okay, wipe it off. Nothing is going to happen, wipe it off. Okay, because it's not there in NCERT, then you people will write and then you will cry. Okay, but they are going to promote. Okay, just if you have written, then just let it be there. Now don't erase it again. Okay, I'll write it off because extra information is good. Okay, promote gastric mobility. Now CCK, okay, inhibit gastric mobility. Secretion of what? All of you tell me in the chats. Very good, Savita. Secretion of water and bicarbonates. Okay, secretion of water and bicarbonates. Very good. Okay, now last is, students, gastric inhibitory protein. You can also call it as GIP. Okay, you can also call it as GIP. Very good. Okay, this one also, students, does the job of inhibition. Okay, inhibits gastric secretions and motility. So this is going to work antagonistic to gastrin. Gastrin is going to release the gastric juices and do the motility. This fellow will do inhibition. Even secretin will do the inhibition. So we have releasing and inhibition function, no? And from the name itself you understand inhibitory. So it has to inhibit something. Yes or no? It has to inhibit something. So it will inhibit the secretions. Okay, clear? This is clear. Learn only this box, don't learn anything else. Just learn this box. These are the ones that are released by your gastrointestinal tract. Okay, you have 4 of them: gastrin, secretin, CCK and your GIP. Okay, GIP, 4 of them. Each of their functions I have given. Please make a note of it and learn it properly. Okay, this is it. This is also what is there in your NCERT as well. See, you can see here, same thing. Okay, CCK acts on both pancreas and gallbladder and stimulate the pancreatic juice. We have written here. Okay, stimulate production of pancreatic juice and bile, release enzyme. Done? Okay. Yes, inhibition is the main job. So here, mechanism. Students, we are going to the last part of this chapter, mechanism. Okay, energy is there? Yes. Okay. Chalo. Hormones produce their effect on target tissues by binding to a specific protein called as hormone receptor. Very simple. Now hormone is there, it is going to come and bind with a receptor. That one we'll call it as hormone receptor. So something went into my eyes. Okay, 1 second. What is it? I don't know what is it. Okay, so hormone produces their effect on target tissues by binding to the specific protein called as hormone receptor. Okay, located in the target tissues only. Right, I told you this. Blood is not going to, okay, blood is not going to be your Swiggy or Zomato guy or your Amazon guy who is going to deliver the hormones that you secreted. Endocrine gland has no ducts. So endocrine gland added the secretions into the blood and told blood, tata bye-bye, you go and do the secretions. Now how is the blood supposed to reach the target organ? How do they know that, okay, I have to reach here, I have to promote this, I have to reach here and I have to do this. I have released androgen, I have released testosterone. Now how do I know testosterone has to go and do the facial hair growth or change the larynx, low pitch voice? How do they know? That is because, okay, I'm not crying, okay, something went into my eyes. So that is because thank you, Tanuja. So the blood is going and doing the job because on the target organ there are receptors waiting to accept the secretions, right? Hormone is coming, receptor is waiting to come deliver here, this is my hormone, I have to do the job. So that helps the blood to go and reach correctly to the target organs, right? Otherwise it would have gone somewhere else, package would have gone somewhere else, got it? So located in the target tissues only. Hormone receptors present on the cell membrane of the target cells are called as membrane bound receptors. Okay, the hormones which are present on the cell membrane, I'll show you, cell membrane, are called as membrane bound receptors, and the receptors present inside the target cell are called as intercellular receptors. So if one is present on the membrane, I will call it membrane bound. One is present inside, I will call it intercellular. Okay, intracellular receptors, mostly nuclear receptors present in the nucleus. Binding of the hormone to its receptor leads to a formation of a hormone receptor complex, just like your enzyme substrate complex, just like your E plus S is equal to product. No, same thing is happening here. Hormone and receptor will bind immediately and physiological change or a response will be created, because what is the job of hormone? It is going to come there, it is going to do that. Okay, it is going to come there and it is going to do the function key. Okay, I have to do the secondary sexual character growth, I have to make sure that the BMR is proper, or I have to make sure that the insulin is there, the glucose level is maintained. So they will come and immediately a response will be created. That is because when a hormone and a receptor bind, they form a complex called as hormone receptor complex. Any doubts? No, right? So look here, each receptor is specific to one hormone only. So each receptor is going to be like, I am going to wait for, let's say, insulin. I will be the only receptor who is going to wait for insulin. There cannot be multiple people waiting for my package. No, I have to only wait for my package. So same thing. Receptor is specific to one hormone only, and hence receptors are specific. Okay. Hormone receptor complex formation leads to a certain biochemical changes. That's what I told you. Response. Okay. Target tissue metabolism, and hence physiological functions are regulated by hormones. On the basis of their chemical nature, hormones can be divided. That means depending on what group of hormones or what is the nature of the hormones, the response will change. Yes, human body is full of miracle. Okay, full of miracle. Water. Okay, okay, full of miracle. So look here, students, on basis of the nature, okay, are they protein, are they steroids, or are they something else? Depending on them, we have 4 categories, and let me tell you, this is one of the most important questions of your NTA. You go check past papers, you will find at least one question from this topic. Okay, because it's a favorite question, because students cannot remember the names. So NTA is like, let me play with them. I will give this only as the question. Okay, I'll give this only as the question. Students, I want all of you to comment how the class was. That will promote and that will help other students to have trust in opening my class. Okay, if you do not do it, then I don't know how I can as a teacher reach a lot of students. Only you can change my name, change my life by dropping that comments and letting other students know that you can trust and open this. I was in the live for 2 to 3 hours and I totally understand what ma'am has taught, right? So you people should do your part and don't fail to do that. Okay, look here students, peptide, polypeptide, protein hormones. Which are the protein hormones? Insulin, glucagon, pituitary hormones, hypothalamic hormones. Okay, so all the hormones released by your pituitary, be it your anterior pituitary, posterior pituitary, all of them is going to fall under your protein hormones, because we never saw the word anywhere else, right? We saw our first steroid hormones were later in the chapter, but starting we never saw any of that. So all the protein hormones, okay, all the protein hormones, all the pituitary hormones, all the hypothalamic hormones are protein hormones. Okay, clear students? Now steroid, where did we see the first steroid hormone? We saw it in the cortisol, testosterone, estradiol, progesterone. In that you remember progesterone, testosterone and cortisol. Okay, now iodothyronins, you have your thyroid hormones. Obviously we saw the name also was like that, right? T4 and T3. Now amino acid derivative, you have epinephrine, that is otherwise called as adrenaline. Okay, otherwise called as adrenaline. Always remember, adrenal medulla, adrenal cortex are not dependent on each other. Okay, if adrenal cortex, the hormones have a deficiency, or adrenal cortex have a tumor, it will not affect the adrenal medulla immediately until it is spreading. Otherwise adrenal medulla, whatever it has to release, that is adrenaline, non-adrenaline, it will go separately. Cortisol, mineralocorticoid, everything will be separate. Okay, question has come 1 year asking that if adrenal cortex have, or they asked about I think aldosterone or something, I'm not sure. They asked about one of the hormones and they asked what would happen to adrenaline. So understand that difference is there. Okay, they're separate, they're individual by itself. So students, which are the peptide hormones or the protein hormones? We have all the pituitary hormones, hypothalamic hormones, as well as your insulin and glucagon. Okay, insulin and glucagon, that is IGPH. Okay, all the IGPH. Okay, Okay, IGPH. Steroids are going to be your cortisol. Okay, C, T, E and P. Okay, cortisol, testosterone, estradiol and progesterone. Okay, progesterone. Then we have iodothyronins. I know you will not forget. You will have all the thyroid hormones. Amino acid derivative also you will not forget. Epinephrine. Only this two you remember. Okay, that is IGPH and CTPE. I don't know, something I have made, students. If you want, you can copy it down. I'm not even going to force. Okay, I give pink hats and can Tarzan eat plants? So that is this Tarzan, this people are going to be steroids. Okay, because Tarzan eats steroids. Okay, steroids, this is protein. Protein. Got it? This too, if you want to remember, you can remember. Otherwise, you can make your own thing. No problem at all. Now listen carefully. After this, I'll explain you with the diagram. Look here. Or hormones which interact with membrane-bound receptors normally do not enter the target cell. So in the membrane, imagine the receptor is there. Okay, they'll come, bind. They will not have to enter the target cell. No, the response will be created by itself. So look here, they do not enter the target cell but generate secondary messengers, that is your cyclic, AMP, IPC, calcium, all of them are secondary messengers who will send the signal. Okay, who is Tarzan is non-veg here. Okay, this is I made the Tarzan, so obviously I can change it. Okay, I remember. Obviously I know, but here Tarzan I made non-veg. I cannot write anything else. What else will I write for P? P, nothing else is there. Okay, this Tarzan, this is Gopika ma'am made Tarzan. So generate, okay, cyclic, AMP, AMP, IP3, calcium are secondary messengers which in turn regulate cellular metabolism. Okay, now students, what is the difference? Membrane bound, that means they are going and binding with the membrane. They cannot enter the target organ. Okay, they are the membrane, they are going to bind with the membrane bound. What they will do, they will take the help of another person because they cannot directly go to the target organ. They are like, let's do one thing, I will take a help of a secondary messenger, right, and I will tell the secondary messenger. Now when you get low marks, you first tell your mom, then through your mom you will make your dad tell. Right, imagine your dad has to come and sign the report card. What will you do? You are membrane bound. You can only stand now outside of your house. You will tell the secondary messenger, that is your mother. Your secondary messenger mother can be AMP, calcium, IP3, any of it. This mother, secondary messenger will go and tell the father. Okay, go and tell the father. Father, okay. Yeah, GM production, very nice. Okay, we'll start a company like that. Hormones which interact with intercellular receptors, that is the steroid hormones and ido. So all the, you know, your who tells students? Okay, here hormones which, I'll do it with another color. I was thinking something. Okay, I'll tell you later. Hormones which interact with intercellular receptors, that is your steroids. Okay, hormones which interact with your intracellular receptors like your steroid hormones, iodothyronin, mostly regulate gene expression or chromosome function by interaction of hormone receptor complex with the genome. Cumulative biochemical action results in physiological and developmental effects. Now with the diagram we have to understand. One second, first we will see the diagram. Yeah, so is this clear? So look here students, this is your membrane bound receptor. This is the membrane. Okay, bilipid layer. Can you see hydrophobic head and hydrophilic tail? Yeah. Okay. Can you see the lipid membranes? Now on the membrane there is a receptor. Now the hormone has come and bind. It cannot reach the target organ directly. So what is it going to do? It is going to do the job of. So all your your protein hormones will be coming under this category. Okay, protein hormones will be coming under this category. What they are going to do? On the membrane there is a receptor. They will come and bind with the receptor. Here they have taken the example of FSH. Okay, FSH they have taken the example. Now they will come and bind here. Whose response you are going to take? If you cannot tell your father, you will take the help of a secondary messenger, and that messenger can be a cyclic AMP, okay, adenosine monophosphate, or it can be calcium, or it can be IP3, etc. Any of this, okay. Now they will create a biochemical response. Okay, they will create a biochemical response. Now biochemical response which will lead to a physiological response, that is your ovarian growth. Now FSH has to do the follicular growth, no, primary to secondary, secondary to tertiary. That is the job. So physiological response, or the ultimate goal is what? To make sure that the follicles are formed. So FSH has come and bound to the receptor. From there it has created a response. It cannot directly go to the target organ. So what it will do? It will use the secondary messenger's help. That could be a cyclic AMP or a calcium. That will create a biochemical response that will finally do the job. Is this clear or not? Please tell me in the chat box. Yes, students, please tell me in the chat box. All of you, I want all of your answers, not just one or two. Yes, quickly. 1 second. Any doubts here? I don't know why, what is happening. Chats are not at all loading here. Even on my phone it's not loading. I think I have to close and check, students. Yes, now I can see the charts. Yes, very nice. Okay, done. This is clear. Now, next one, next category is what, students? The hormones that can directly come inside. Okay, hormones that can directly come inside. Now look here, hormone is there, estrogen is there. Okay, estrogen, where did you study? Which category it is coming? So look here, this estrogen will directly come inside. So this is going to go into the intercellular or the nuclear receptors. Okay, estrogen will come here. It will directly enter hormone receptor complex, right? It is directly getting into the cell. This is the membrane. Okay, this is the membrane. It is directly getting into the cell and it is going to combine with your DNA and do the rest of the process. Okay. Any doubts here, students? Please let me know in the chats. I'm going to draw and show you one thing. Okay. Okay. Yes. Hi, Anjali. Okay. Clear? Chalo. Now look here. What I will show you is, now students, they told, so I'll just give you a general idea about whatever we just discussed right now. They told that there are two types of receptors. Yes or no? They told that there are two types of receptors. One receptor is called as your extracellular. They're outside, okay? They are in the membrane. So they are called extracellular receptors. These are present where? Now imagine this is the membrane, okay? This is the membrane. On this membrane, the receptors are going to be there. Let's say this is the receptor. Okay, this is the receptor. This is present where, students? On the membrane. Okay, on the membrane. Right. So I will call this receptor as a membrane bound receptor. What will I call it as? Membrane. Okay, all of you are here? Okay. Membrane bound receptor. Membrane bound receptors. So on the membrane bound receptors means what? Now the something, okay, the thing will come and bind, right? The hormone will come and bind. Now the second one, second category, they called it as, this is extracellular on the membrane, membrane bound receptors. Second one is called as nuclear receptor, okay, receptor or intracellular receptor. Intracellular, they could be present on the nucleus, okay, present on the nucleus Okay, they'll be present inside, okay. Intercellular there, intracellular, they could be present on the nucleus or they'll be present in the cytoplasm, okay. So that is extracellular, which is also called as membrane bound receptor. These are nuclear receptor or intercellular receptors. These receptors mainly will be used by your steroid hormones, okay, steroid hormones and your thyroid hormones, okay, thyroid hormones. Okay, steroid hormones and your thyroid hormones, etc. Many other hormones will be there. These are the main people who will use this. These will be mainly used by your protein hormones and the rest of it, okay. Yes, membrane bound receptors. Now students, what is going to happen in the second? The first one all of you understood, no? Let's say here, okay, here this is the membrane. Okay, this is the membrane. On the membrane there is going to be a receptor, okay. On the membrane there is going to be the receptor, okay. This is the receptor. Now we'll erase this line here. Oh, okay, let's just erase the line here directly. What is going to be there? Here the receptor is going to be there. On to the receptor they have taken FSH, okay, FSH as the hormone, so it will come and bind here, okay, it will come and bind here. Now this one cannot enter inside, so what it is going to do? It is going to take the help of a secondary messenger, okay, it is going to take the help of a secondary messenger. That could be what? Secondary messenger. See, response 1 will be created the moment they bind. Here a response will be created, that will be a hormone, okay, hormone receptor complex, okay, that will happen. No doubt in that, one response will happen that will form the hormone receptor complex, okay. Now secondary messenger could be your AMPs, calcium, in case you forget one you can write other ones, okay, or IP3. Any of this could be a secondary messenger. This will create a biochemical response, okay, this will create a biochemical response and this response will create a physiological change. Physiological change. Clear? So in FSH case, the ovarian follicles, okay, this is how the membrane bound will act, okay, membrane bound will act. Yeah, so here this is what will happen. Now here next one, next set, okay, this is your membrane, okay, this is the membrane. To the membrane what is going to happen students? An hormone will come. This is too small, no? A hormone will come. This hormone will direct enter inside, okay, it will directly enter inside to where? Ayo, one second, just give me time to draw. Okay, it will directly enter inside the cell and it will go inside the nucleus, okay, it can go inside the nucleus. Let's say this is the cell, okay, this is the cell. Okay, this is the cell. Inside the cell, let's say one receptor is waiting, okay, one receptor is waiting. To this receptor it will come and bind, it will come and bind. So this is going to be intracellular, right? The receptor, it will come and bind. After this binds with the receptor, what is going to happen? It is going to, okay, DNA, from DNA it will form RNA, that is transcription will happen. From RNA it will form protein and that protein will cause the change, okay, physiological response. Clear? Clear? Yeah, no securities to stop this hormone, exactly. No securities to stop this hormone. Okay students, is this clear? Any doubts? So I'll label it so it will be more clear for you. Okay, this is the cell membrane, right? This is the nuclear membrane. So let's say this is a nuclear receptor, okay? Nuclear, this is going to be your nuclear membrane and this is going to be your nuclear receptor, okay? Nuclear receptor, okay, binding has happened. then this will go into the DNA. From DNA to RNA, transcription will happen. Okay, transcription. From RNA to protein, translation will happen. From translation, finally the physiological response will happen. So this is what is going to happen. This is your lipid membrane. Okay, this is the cell membrane. So can you see two different ones? I have drawn simultaneously that side, this side, so it is clear for you. Okay, clear for you. Got it? Yes, all of you? Any doubts? Please let me know. So this is the difference. Okay, this hormone will directly come. Let's say this is, they have taken estrogen. Okay, they have taken estrogen. You can even take cortisol or any of it. So if you have taken estrogen, it will come in, right? It will come in, and finally the physiological change will be the growth in the secondary sexual characters. Now here if it is FSH, okay, here if it is FSH, then here you will have the ovarian, right? Here the formation, the follicles, right? Formation of follicles. Formation of ovarian follicles. Okay, formation of ovarian follicles. Done, done, done. Clear? Any doubts? Okay, clear. No doubts. Fine. Now this diagram also I have done. Shall we do some? Okay, students, I have just taken the summary, so I'll share the summary also with you people. Just go through the summary. This will give you an idea about what and all we have learnt, right? So here if you see, this is actually an overview of the entire chapter. Overview of the entire chapter. I don't even have to underline because that much is there. See, there are special chemicals which act on hormones and provide chemical coordination, integration, regulation in human body. These hormones regulate metabolism, growth and development of our organs. This you can skip. From here it is very important. See, the endocrine system is composed of hypothalamus, pituitary, pineal, thyroid, adrenal, pancreas, parathyroid, thymus, gonads. Okay. In addition to this, there are some other organs like gastrointestinal tract, 4 hormones, gastrin, secretin, CCK and your GIP. Kidney, JG cells which release your erythropoietin. Heart, ANF, atrial natriuretic factor. Also produce hormone. The pituitary gland is divided into 3 major parts which are called as pars distalis, okay, pars intermedia, also called as anterior lobe, intermediate lobe and your posterior lobe. Okay, posterior lobe. Got it? Yes. Pars distalis produces 6 tropic hormones. So this pars distalis means your anterior lobe forms 6 tropic hormones like your ACTH, prolactin, growth hormone, releasing hormone, inhibiting hormone. 6 of them they will form. Pars intermedia secretes only 1 hormone which is called as your melanocyte stimulating hormone. Okay. Then see, only 1 hormone, and the pars nervosa which is your neurohypophysis or the this is like your Gopika ma'am express only. Okay, take it same way. Pars nervosa, that is your posterior lobe, will release 2 of them, vasopressin and oxytocin, which will be directly given by the neurosecretory cells. There is no hypophageal portal system at all. Directly the neurosecretory cells will add the secretion into the posterior lobe. Okay. Now look here, the pituitary hormones regulate growth and development of the somatic tissues and activities of the peripheral endocrine system. Pineal gland secrete melatonin, which plays an important role in the regulation of your sleep cycle, sleep and wake up cycle. And look here, rhythm of sleep and wake up. Now the thyroid gland hormones plays an important role in regulation of the BMR, development and maturation of the central nervous system, erythropoiesis, metabolism of carbohydrates, proteins, fats, menstrual cycle, etc. Okay, these are all the functions of your thyroid gland. Now another thyroid hormone which is called as thyrocalcitonin, it does the job of regulating the calcium level, that is decreasing the calcium level that is increased by your parathyroid hormone. Okay, done. Now the parathyroid hormone secrete parathyroid gland secrete parathyroid hormone which increases the blood calcium level and plays a major role in calcium homeostasis. Now the thymus gland, thymosin, mainly helps in the T lymphocyte maturation and differentiation that helps with the immune system. Okay. Now addition, okay, adrenal gland. Okay, adrenal gland is centrally located. Adrenal medulla is there, cortex is there. Adrenal cortex has 3 parts: zona glomerulus, zona fasciculata, zona reticularis. Each of them secrete 1 hormone. So you have to remember glucocorticoids, okay, mineralocorticoids, glucocorticoids, and your sex hormones are released. Sex corticoids, okay, small of them will be released. Okay, clear? Now Adrenal medulla secretes epinephrine and your non-epinephrine or adrenaline or non-adrenaline. They are amino acid derivatives. Okay, amino acid derivatives. Now, these hormones, what do they do? Pupillar dilation, alertness, the heartbeat increases, blood pressure increases. They also sweating, thirst, all this you will feel if these hormones are released. Now, look here. Yeah, then catecholamines, that is your adrenaline and non-adrenaline, also helps with glucose formation, breakdown of lipid and breakdown of protein. Okay. Now, adrenal cortex secretes glucocorticoids, mineralocorticoids. Glucocorticoids stimulates gluconeogenesis, lipolysis and proteolysis, erythropoiesis, cardiovascular system, blood pressure, glomerular filtration, and inhibits inflammatory response, suppressing the immune response. My God, everything is here. Okay, everything is here, right? Every function is here. Now, the endocrine, pancreas secrete glucagon and insulin. That is your pancreas, islets of Langerhans, which constitute 1 to 2% of your endocrine gland or 1 to 2% of your pancreatic tissue. They will release alpha cells and beta cells. Alpha cells release glucagon, which will make an hyperglycemic condition, and beta cells releases insulin, which causes a hypoglycemic condition. These two people will balance. Then you have beta cell, which releases somatostatin, which is a growth inhibitory hormone. Okay, growth inhibitory hormone. Okay, so here glucagon stimulate glyconeolysis and gluconeogenesis, resulting in hyperglycemia. Insulin stimulates cellular glucose uptake, utilization and glycogenesis, resulting in hypoglycemia. This is what I told you. If deficiency of insulin is there, it will cause diabetes mellitus, and if there is a deficiency of water in your body, it will cause diabetes insipidus. Okay, understand the difference. Yes. Okay, now testis has two jobs, that is dual function. Even the ovaries has dual function, acting as the primary sex organs, which does the job of producing ovum and doing spermatogenesis. At the same time, they also release androgen, that is your testosterone, which will do all the secondary sexual characters, also help in the male accessory organs like your seminal vesicle, prostate gland, epididymis, vasa deferens. Okay, got it? Now, the ovaries, what are they going to do? They also have dual function. Again, they will act as, they will release ovum every menstrual cycle. At the same time, they also release two steroid hormones called as estrogen and your progesterone. Okay, estrogen is a steroid hormone. That is why we learned it under intracellular receptors. Okay, intracellular receptors, you studied estrogen. They are steroid hormones. Two of them will be released. Estrogen, which takes care about all the secondary sexual characters, which are mainly released by the follicles, especially your graphene follicle. Then you have progesterone, which is released by the corpus luteum, which is going to help in the maintaining of the pregnancy. At the same time, they are also going to release corpus luteum is also going to release relaxant during the parturition time to smoothen the ligaments and the muscles, okay, to help in easy parturition, and they are also going to help in the formation of alveoli, that is the milk gland, okay, alveoli, mammary alveoli, which is going to store the milk and also help in secretion of the milk. Okay. Okay, now students, look here, done. Okay, next we have some additional hormones like your ANF, that is atrial natriuretic factor, released by the atrial walls, which are actually tissues. Then we have kidney releases JG cells. JG cells releases erythropoietin, which also helps in erythropoiesis, formation of RBCs. Then you have heart done. Then you have that is your gastrointestinal tract, releases 4 hormones: gastrin, secretin, CCK and your GIP. Each of their functions I have already mentioned to you. Those are the addition. Then mechanism of hormones. Mechanism of hormones can be categorized based on the nature of the hormone and the type of the hormone. If they are peptide hormones, what they will do, if they are steroid hormones, if they are iodothyrosin, and if they are amino acid derivative. 2 types of receptors are there. One is called as membrane bound receptors, one are called as intracellular receptors or nuclear receptors. Now, membrane bound receptors, they will have the receptors on the membrane and they will go and attach to the membrane. They cannot directly reach the target organ, so they will take the help of a secondary messenger like your AMP, IP3 or your calcium. With the help of a secondary messenger, they will pass on a biochemical response, and that biochemical response will make a physiological change. Okay, at the same time, you have an intracellular receptor or your nuclear membrane that will do the job of this hormone will be able to directly reach into the target organ or directly into the nucleus of the target organ or the cytoplasm. They will go there, they will bind with the DNA, convert the DNA into RNA by the help of transcription, then translation, and finally do a physiological response. Done? Done? This is the entire summary. My God. Can you all tell it in one break? Vande Mataram, it seems. Okay, Vande Mataram, yeah. Faster than Vande Mataram it was. Faster than Vande Mataram or slow than Vande Mataram? Yeah, right now I took a breath. Okay. Yes, ready for quiz? Lecture 1, lecture 2, both revision is done. Okay, lecture 1, lecture 2, both revision is done. Faster than Vande Ma'am. Thank you, Madhumati. Thank you, Tanuja. Thank you, Deekshi. Yes. Okay. Okay, done. Ready for quiz? Okay. Okay, chalo. First question. Which of the following hormone is secreted by posterior pituitary gland? Very easy. Posterior pituitary gland. Okay. Which hormone is secreted by the posterior pituitary gland? I will sit. You guys tell the answer. Okay. 2 minutes. Just keep telling the answer. I will see your answers. Which of the following hormone is secreted by the posterior pituitary gland? Okay, Madhumati, Ratis. Can I get some water? Okay, I'm out of breath because of your Vande Mataram. By then tell the answer. Okay, many students have to still tell the answer. Tell the answer. Yes, very good. 3. Okay. Okay, chalo, I'll take the water later then. Okay, very good. Oxytocin is the answer. So, posterior pituitary releases only 2 hormones, vasopressin and oxytocin. So, you should never have the confusion. Okay, you should never have the confusion. Got it? Which of the following hormones is secreted by the posterior pituitary gland? You should not have a confusion. Chalo, next question. Now, I'll go take the water and come. By then, you read this question. Okay, the deficiency of which hormone leads to diabetes mellitus? Oh, this mic. Yes, what's the answer? Very good, very good. Okay. Yes, deficiency of insulin causes. Okay, what happens? No, normally students, as soon as they see diabetes mellitus, no, they'll go for glucagon. Okay, so don't go for glucagon. Insulin deficiency will only cause diabetes mellitus. Okay, insulin is less. That is why hyperglycemic condition has come. Okay. Now, next question. Which of the following hormones is involved in the regulation of calcium and phosphorus metabolism? Okay, calcium and phosphorus metabolism. Think and tell. Calcium and phosphorus metabolism. Which of the hormone is involved? Calcium only, if you see, you will be able to understand. Okay, you don't have to think so much. Yes, who's going to tell the answer first? Very nice, very nice. B for Baswa sir, that is parathyroid hormone, right? So thank you. So B for B, parathyroid hormone. Students, I know phosphorus might, confuse all of you, but look at the word calcium. Okay, calcium, only two people are there, that is your TCT or your parathyroid. Parathyroid is the one who will keep increasing the calcium, right? So that is parathyroid hormone. Now, which of the following pairs is correctly matched? Yes, correctly matched. Which is correctly matched? Glucagon decreases the blood sugar, insulin increases the blood sugar, thyroxine stimulates metabolic rate, calcitonin increases the calcium levels in the body. Which one is correct match? Yes. D for Diksha ma'am. Tanuja, check once again. Check all of you once again. Calcitonin increases calcium level, decreases calcium level. Who increases the calcium level? Parathyroid. Yes, someone got it. Someone got it. Yes. Who is that? Who is the first person who told? Sony. Very good. Right. What is the problem, students? Look here. Calcitonin will decrease the calcium level, not increase the calcium level. So the only answer which is correct is thyroxine. Okay. It decreases the calcium level. Just now I told you people parathyroid increases the calcium level. Suddenly people have gone and answered the next one wrong. Okay. Next question. My God, it's such a long question. I don't know if you'll be able to see. Look here. Which of the following are not steroid hormones but still do not act through secondary messenger system, are small, non-polar and can be taken orally? Okay, so they are asking which are not steroid hormones but they still do not act through secondary messenger, are small, non-nuclear and can be taken orally. Okay, try to answer. If you cannot, it's okay. They can be taken orally. That you have to remember, think and tell. Okay, if peptide hormones are taken orally, it will get digested in the stomach because there is pepsinogen. Okay, so think that way and understand. They are not steroid. Not steroid means it does not fall under estrogen, CTEP. Okay, can Tarzan eat plants? It does not fall under that. Ready? Anyone give it a try? Until you people answer, I cannot move forward. I think someone will tell, hey, Saheli, one I'll give you people. Yes. Try to answer. Very good. I think, did you guys answer for this one? 4 did you answer? So look here, which is not, okay, it is not a steroid hormone but do not act through the secondary messenger system, small, non-polar and can be taken orally. Say insulin and glucagon you completely remove because you cannot take it orally. Okay, steroid and progesterone we can take it orally. Thyroid hormones, yes, we do take tablets for it, but the answer will be, see, estrogen and progesterone are steroid hormones. So this is also removed. This is the confusion that will come because this will be taken orally. Should I do this? So go for this. Okay, thyroid hormones. Yeah, guess 4 good. Okay, thyroid hormones, not insulin and glucagon, thyroid hormones, because see, this one is non-steroid. Okay, it's amino acid derivative and it is not it can be taken orally. Estrogen and progesterone can be taken orally but they are steroid hormones. Okay, that just kuchak puchak you do this, you'll understand. Okay, next one. Which of the following regulates carbohydrate, protein, lipid metabolism in a manner opposite to that of insulin? Oh, which of the following regulates carbohydrate, protein and lipid metabolism in manner opposite to insulin? Opposite to insulin. Yeah. So that's why I told you. If you will tell B, because estrogen and progesterone, we have studied in reproductive health that pills are there and we can consume it. But the problem is they are telling it is not a steroid hormone. So then why will you tell estrogen and progesterone? Understood? So go for thyroid, amino acid derivative. That's all. Like that small hints they'll give you in the question. This one, students, it should regulate. Okay, it will regulate. So that means insulin will do the job of lowering the sugar level. So this fellow, it need not be glucagon. Okay, it need not be glucagon because we never studied about glucagon that it is going to do all this. So think properly, something that will release glucose. Okay, something that will release glucose and increase the glucose level in the body, and it is acting opposite to insulin. I have given you the hint. More than this, if I give you the hint, answer only will come out. Okay, I'll tell off the answer. So don't think it can only be glucagon, it can be something else also. Who did all this function? Carbohydrate metabolism, proteolysis, lipolysis. Go check my notes. Okay. See, this is the kind of questions that will come for NEET. Small understanding, you will get it. Okay, Balaji is telling one answer. Madhumati is telling one answer. Paul told. Okay, I think all of them agreed for 2. Oh, I didn't put the answer for this. For which one did I put the answer then? Okay, I put for this. Yes, perfect, correct. Because cortisol, look here, cortisol can regulate carbohydrate, proteins as well as lipid, that is they are doing breaking down, and cortisol also has a job of converting glycogen to glucose. That is, they are increasing the glucose level, and also they are inhibiting the cellular intake. So that means it is doing exactly opposite to insulin. But here, glucagon, if you go for the answer, we never spoke about carbohydrate, we never spoke about lipolysis, we never spoke about proteolysis. We spoke about formation of glucose, breakdown of glycogen to glucose, but we did not talk about this, no? Right, this we did not talk. So that's why you will go for answer number 2, okay, cortisol. Next one. Which hormone stimulate exocrine pancreas to secrete water and bicarbonates? This you know. This all of you know. Tell me answer. All of you know this. Students, the questions I have put is a very little difficult questions only. It's not easy. So don't get discouraged because you're not able to answer. See, you can look here how many people have done it right. Look at the percentage. Here it is actually, I think 50 or 40% people have done it right. Here also look at the percentage, only 51% have done it right. So these are difficult questions actually, okay. These are AIMS level difficult questions, so don't get discouraged. First time you are learning the chapter, definitely by next time you will be able to answer the question very easily, okay. Yes, very good. What will they secrete? Water and bicarbonate, okay. Answer is going to be secreted. Very nice. Okay, done. Okay, last question, students. Last question. You can do it as homework, or you can give it here only. Tell it here. Which hormone is responsible for the maturation of graphene follicle? Maturation of graphene follicle. Yes. I did this, no? I drew the diagram and taught you. Yes, good job. Good, good, very good. Very good, very good. FSH, follicle stimulating hormone, and that is the last. Okay, follicle stimulating hormone. Very good job, good job, good job, all of you. Okay. So students, again here, some students are asking me, ma'am, how do I register for MVSAT? I'll just show you. Students, enter your phone number. Okay, just enter some phone number here. After that you will be able to get, see, complete nationally 1 crore worth prize, 100% scholarship on online and offline courses. You can also get your pro batches for completely free. Offline test is going to happen on 26th September and on 6th, 13th, 20th and 24th October. That means you will be able to go to your offline centers, right? In Chennai we went, Anna Nagar, Tirchi, like that, different places offline centers are there. In the offline centers, the exam will be conducted on 28th September, 6th, 13th, 20th, 27th October. In online, it will be conducted from 10th to 20th. We will give you the information about that, and scholarship up to 100%. You can get your entire pro batches for free, and this way you will be able to get a lot of free things, right? Maybe you will get a phone, maybe you can get a PS5. PS5 is like boys' biggest dream, no? So you'll be able to get that, but most importantly you will be able to get a 100% scholarship, which is the most important thing. This phone and these things are not important now. Right now you need to make sure that you get into a good coaching center without paying any money, which is a blessing, right? So using just the information that you have, the learning that you have, the knowledge that you have, you will be able to get an entire course for free. So students, try to write the exam whenever possible. Write any of these dates if it is possible for you to visit the offline center and write. Do it, because it will give you the competition. You will understand the real competition, and also it will give you that you will get rid of the exam fear, so your adrenaline and non-adrenaline does not go crazy on the exam day. Okay, so I hope all of you are here with me, right? Let me see some. Okay, here it is. Okay, yes, very nice. Okay, very smart you people are. Okay. Okay, so thank you so much for joining. I hope the session was really helpful. So see you all in next class with another session. Saturday's class, again, it will be preponed. It will not be postponed. It will be preponed. I will change the timings maybe 1 hour before. It will not be at 6 o'clock because it's my festival. So I hope all of you will respect that as well and join the session. And I want all of you to comment and let me know in the chats how the session was. Thank you so much for joining. Any doubts, please let me know in the comments. See you all in the next class. Tata, bye-bye.